Hi everyone, welcome to yet another video tutorial on the top 10 reasons to learn Python in 2022. Python's popularity has grown exponentially over the past few years and is being widely used in different jobs. So this video will focus on the different reasons why it is important to learn Python in 2022. Let's begin. The first reason we have is Python is versatile. Python is a totally versatile language as it is being used widely in artificial intelligence, data science, machine learning, web development, embedded systems, graphic design applications, data mining, gaming, and others. Python is used as an easier and more effectively written alternative to languages that perform similar functionalities like R and Java. Now talking about the second reason why you should learn Python in 2022, we have Python is the fastest growing programming language. Python programming has become one of the fastest growing programming languages in the world and is the primary language for many applications. Its popularity has grown both in India as well as in the US. In January 2021, Python was in the third position in the TOP index. In January 2022, which is this year, Python has become number 1 in the TOP index of popular programming languages. The ratings are based on the number of skilled engineers worldwide, courses, and third-party vendors. Popular search engines such as Google, Bing, Yahoo, Wikipedia, Amazon, YouTube, and Baidu are used to calculate the ratings. Coming to our third reason, that is Python is beginner friendly. The main reason why Python is an excellent choice for beginners is its simplicity. Python supports English syntax and is designed to be concise and easy to read, all of which make it more accessible to first-time coders. It is an interpreted programming language. This means that you can run each line of code once you have finished writing it, allowing you to immediately check it and make adjustments if needed. The fourth reason we have is Python libraries and frameworks. Python provides numerous libraries and frameworks that cater to every need of the user and its clients. It has Numpy and Pandas for numerical computation and data manipulation, SciPy for scientific computation, Matplotlib and Seaborn for data visualization, scikit-learn for machine learning, statsmodel for statistical analysis, and much more. Python also supports frameworks such as Flask and Django for web applications. You can also do cross-platform and cross-browser testing with frameworks like PyTest and Robot. Now moving ahead, the fifth reason we have is Python for data visualization. Python is a great programming language for data analysis and data visualization, so it supports libraries such as Matplotlib, Seaborn, Bouquet, and Plotly for creating interesting visualizations. You can make sense of complex datasets and visualize your findings through various representation options like bar graph, pie charts, graphical plots, geographical maps, and much more. Now moving ahead, the sixth reason we have is extensive online documentation. Python has been adapted to the latest advancements with developers continuously releasing new and improved versions. Python language is very organized and its libraries have coexisting documentation, letting you jumpstart straight into programming. You will also find example codes where you can see the functions implemented, so reading the documentation is a good way to improve your knowledge about Python. Moving on to the seventh reason why you should learn Python in 2022, we have Python is great for scripting. Python is also used to write scripts to do automated tasks such as backups and cleanup in servers. In Python, you don't have to compile the code in order to interpret it. You can directly write code in the script and execute it. The machine reads, interprets, and runs the required tests and also performs error checking. Now coming to the eighth reason, we have Python for cybersecurity. Python has been dominating the cybersecurity industry and has been around for a long time now. It can help to automate tasks across the cyber attack lifecycle for both cyber attackers and defenders. You can develop custom Python scripts to automate cybersecurity tasks with libraries such as Nmap, Yara, Skippy, and Twisted. Python is used heavily in malware analysis, host discovery, sending and decoding of packets, accessing servers, and network scanning. Now moving on to our ninth reason, we have Python community support. You always need a community to learn new technology, and friends are your best asset when it comes to learning a programming language. The Python programming language has a global community with millions of software developers who interact online and offline in thousands of virtual and physical locations. In case of any coding related issues, you can always seek help from the Python community. As shown on the screen, Python has a robust and supportive online community with over 1.5 million GitHub repository. Communities such as Stack Overflow also bring several Python experts together to help newbies. Now moving on to the 10th reason in our list, we have Python jobs in high demand. As Python is getting more popular, along with an increase in an active community and its functions, the demand for Python professionals is also increasing. Python jobs are increasingly growing in every business sector and provide high salaries. Python developers is one of the highest paid jobs in the United States. The average salary of a Python developer in the US is over $96,000.
Today we're going to cover Python, one of today's highly utilized programming languages for its many diverse uses. I'll be working in PyCharm. PyCharm is put out by JetBrains. That's www.jetbrains.com/pycharm/ where you can download it. The benefits of using PyCharm is it creates an virtual environment, so you can change what version of Python you're using. You can make all kinds of alterations in there. For this tutorial, any Python IDE will work, but we'll be in the PyCharm setup. It is a really good setup to use on there. And again, you can download it here from the JetBrains website. So in the PyCharm environment, and if you're not using this, you'll need to follow whatever IDE setup you have for doing a new project. We've created a new project and we're going to create a new Scratch file. This Scratch file we can call whatever it is we want. It's going to be a Python file since we're working in Python. We'll call it Scratch 3 Python. We can also rename this. You can see I have a number of other Scratch files. Delete them, remove them, whatever you need to do. So we're going to be working on our Python in this IDE, and again, whatever IDE you use will work just fine for this Python tutorial. And we're going to start with variables in Python, the most fundamental building block you need. Variables are entities of program that hold a value. X equals 100. The box is holding a variable would be the name given to the box. And if you studied basic algebra, x equals 3, x equals 100, it goes a little bit beyond just equaling numbers because we can also do words. But we're going to look at just variables. And let's go ahead and pull that up in our user interface and see what that programming looks like in the script language. So in Python, we can do something like print. This is a simple print statement, so whatever we put in here is printed back out. So we're going to put in here meet Jane, and let's also have it print Jane works as a software engineer. And then let's also do one more print line just so you can see what we're looking at. Print, and then we have Eli's is Jane's manager. And in here, you can run it a number of ways. We'll go underneath run, and here's our Alt-Shift F10 also does this. And it asks me, what do I want to run? I want to run the Scratch 3 because I have multiple Scratch files in there. And we'll click on there and it'll run it. If you're on like a different ID, you might pop up with a black box that prints it out. And you can see here it says meet Jane. Jane works as a software engineer. Elise is Jane's manager. You can always take that space out so it just looks nicer. So we have that, and it's kind of nice if you just want to print something out. And there certainly is a lot of times when you want to print the title of something. You might have your HTML code on the server and you print it out, and that's what people actually see. If they go to the Python and it accesses that Python code, it'll print out the HTML and it'll just be text printing it out. Now, this is all great. Let's go ahead and put a comment in here just so we can track what's going on. A comment uses the hashtag. So this just tells it this isn't code. This is just a comment for our notes while we're programming. And this over a little bit so you have better space on here. Instead of typing Jane, every time we can also store it as a variable. So let's go ahead and store that, and we'll call it name equals Jane. So now we have the variable name. And now we can do something like this. We can go print, there's our brackets, we want meet, And I'm just going to do a simple comma. Everything that's separated between commas, they'll print out in a row. So we have meet, and then we'll just do the name. And if I run this, you'll see meet Jane. Jane works as a software engineer. Elise is Jane's manager. And then it just says meet Jane because we replaced the name with Jane. And we'll take this off the top. I'm just going to delete that out of there so we can move on to this next setup with variables. And we can also go print. This is kind of a cool system because I can now do string. We can hold a space for a string. Works as a software engineer. And then if you're going to put a placeholder in there, it has to know what the placeholder stands for. And this is one of the formatting options when you print something out. So I'll do something simple like this. We have a placeholder for a string, works as a software engineer, except the placeholder is supposed to be inside the brackets. And when we hit run, you'll see meet Jane, and then it also prints Jane works as a software engineer. You can see that right down here in the output, the terminal output from the run. So instead of having to type Jane over and over again, we can now put a placeholder in there and do the same thing with the last setup. Print Elise is, and there's our placeholder, the percentage sign and the S, and then we have name afterward. Let's go ahead and run that. And you can see here that we've now printed out the first one, meet Jane. And notice that this puts a little bit more, it has one space in here, but you don't really control the spacing on here. So when we do a formatting and we insert it as part of the format, you can see right here we put the name. It now has a nice format. Like I couldn't do this with a comma, but I can certainly do this down here with the apostrophe S for Elise's Jane's manager. And then we can also, instead of having Jane up here, maybe Jane got fired and May got hired. Well, let's just say there's a second employee named May. So now we have the name May in here, and I can run this, and you'll see it now prints meet May. May works as a software engineer. Elise is May's manager. So we've just swapped May in for Jane. And then one other important feature of Python variables is we could have name2 also equal to May. Keep the same name on there. And let's go ahead and print. We'll do ID of name, and then I also want to print the ID of name2. And what the ID does is the ID goes in there and says, hey, where is this name coming from? Let's go ahead and run that, and you'll see it actually gives us a memory address. And so one of the things that you find out about Python is to help save memory. Let me just swap this out here. In Python, variables with the same value hold the same memory space. So when we have name equals to May, name2 equals May, we print the idea of name and name2, and you'll see that they occupy the same memory space. Now, if we happen to swap one of these out, we'll do Jane again, and we run it, they now have two different memory spaces. So even though I make changes in here, this is one of the ways that Python's really good about saving memory in the computer. And the last thing we want to note here, which leads us into the next piece of programming, is that this is a string up here. Name equals Jane. So when we're talking about different data, we really have to also talk about different data types. And very specifically, we're going to look at numerical data. So when we talk about numeric data, talking numbers, the various types of numeric data are integer, float, and complex. There are in advanced programming additional numerical data types which have to do how it stores the data. But these three are the ones that you need to know about to get started in your scripting language and the most commonly used. And so an integer is just simply that. It's a number equals 5, and then if I print, and you can always find out what type of variable you have if you do a type on it. So we're going to print type number. And so if I run this, it comes out and it says class integer down here. So this is an integer number. And you can also do negative on these. So if I run -5, it's still a class integer, whether it's plus or minus. And the second most commonly used number is your float. And it's just like it sounds. We have, let's do a number equals 5.6. And if you notice, I used the same variable name num on there. So I can actually take this and I can just copy this. And at some point we'll talk about ways of not having to recopy your code so you can create definitions. But let's go ahead and take a look at this. So we have our float. Our number now equals 5.6. And if we print the number type, we'll see that it is first an integer and then a float value. And let's do this just to number, just so we can remember what we're looking at. Number. And then finally complex. So if we have a complex number, we'll go ahead. I'm going to keep number in there. Usually you don't leave it as number because then it confuses the code later on. But just for this particular piece of code, we're going to keep it number. And I'm going to do 5 plus 6j. And let's go ahead and print that out so we can see what these look like. And here's our number, comma, type number. And let's run this. And let's see what we got here. We have a 5, which is an integer, 5.6, which is a float. So it has a decimal place there. That's what the float stands for. So your 5.6, 5.6, 5.7, 5.8, and then we have 5 plus 6j is a complex number. And if you remember from math, complex number is based off of I squared equals minus 1, or the square root of minus 1 is that imaginary number. Now, I'll be honest with you, I don't use imaginary numbers much unless something comes up where I take a square root of a minus 1, and then I end up with a return of a complex number. So it's important to know it's there and know what it is when it comes up. And with anything, you do have to pay attention when you do conversions. So we can convert these things back and forth. And let's go ahead and put a little note here, conversions. And let's start by, let's just do, here's our print. And we'll go ahead and do our number, comma, type, back to what we were doing before, so we know what the type it is, and type number. So that's just from before on there. And let's say we want to convert it from a regular number to a float. And we can simply do something that looks like this. And let's go ahead and pull ways. There's our number, but I want to convert it. So I'm going to convert it to float. And then if we do that over here too, and I go float, that in brackets. So we're going to print this out, and if I run this, we now have 5 is a class integer, 5.0 is a float. So I've converted it to a float here. And we can also convert this to a complex, just like we did here with float. I can simply put in complex. And we'll do that over here also. Complex number, and if I run this, we now have 5 plus oj. So this is a complex number. There's no actual negative imaginary numbers as part of it, so you're going to get just a 0 in the j part. So this is one way to convert it, and you convert it this way. We can also convert it back. So you can convert to between any of these. And let's take our number, and let's make it worth 5.6. So if you remember correctly, this is now a float. And if we wanted to take that float value, print integer of our number, and then of course type integer of our number. And if we run this, we started off here with 5.6, so by default it automatically makes it a float value. And here we have it, we converted a float to a float, so it's not going to really do anything. And then we convert it to an integer. And look what happens as an integer. As an integer, it just truncates the 6 right off. So you got to be very careful when you're going the wrong direction on this. So if you're going from float to integer, you're going to lose a decimal value. If you're going from integer to float, which is a very common thing to do, especially with data science, you don't lose anything, you just gain the decimal place. So if we did it earlier, we had 5 became 5.0, and then you can see where it becomes a complex number. And we can do that just about any direction you want with the conversion. Python's really nice that it lets you do that, but you do have to be careful that you don't lose information that you need. So we've looked at variables, we've looked at numerical variables and how they differ. The next question is, what happens if you have a lot of data? You really can't just number 1, number 2, number 3. That's really not going to work in programming. So 3 of our basic lists is lists in Python. A list is a collection of data, and it can hold values of multiple data types. So you can see here we've set a value, a variable x, and we'll set it equal to 189a hey 0b, and it can store that in there. There's also the tuple. So we have list, tuple, and set. The tuple almost has the same format as the list, but instead we put the curved brackets around it. And what this means is a tuple is an immutable collection of heterogeneous data. Big mouthful there. What it means is once I set the tuple, I can't go in there and change one piece of it. As far as the tuple is concerned, that's one variable. Where a list is a list of subvariables, 189a hey 0b. A tuple, you can't change anything in here. Now you can access it the same way you do a list, but you can't make any changes on this tuple other than completely overwriting it. And then finally there's a set, and we put brackets around it. Now there's some other more complex data sets that go with this, that go above, or data type collections of data, but these are the 3 basics. And a set is an unordered collection of unique heterogeneous data. So it's unique. So if you put in 153 hey 6 Python and I try to add 6 in here, it will only store one value of 6, since these are all unique in here. So let's jump into our IDE and let's create a list. Remember, it uses square brackets. That's how we denote that this is going to be a list. Let's just throw some numbers in there. 4, 5, 7, 5. So now I have a list. And we can do a simple thing like print the list. And if we run this, we'll see it come out down here as 1, 4, 5, 2, 7, 5. And one of the cool things about lists is that these are indexes. And this is kind of important to understand what the index means. So we'll go ahead and print list, and it always starts with 0. So if I run this and I print 0, it's going to print the 1, because that's in the 0 place. And if we print, Here's our list. We print a 1 on there, and we run that. We have 4, because that's in the 1 place. So 0, 1, 2, 3, 4, 5. So there's 0 through 5. And this is interesting because if we print, let me go back up here to the top. I'm just going to print len, which stands for length of list. So this is going to return the length of the list, and I'm going to run this. And you'll see it says there's 6 things in there. But it starts at 0, so we reference them as 0 through 5. Now, if you're new to this, that can be confusing, especially when you're jumping back and forth in your code. So always remember this is point 0 through 5. It's not 1 through 6, it's 0 through 5, but there are 6 entities in the list. That's the length of the list. And we showed you here where you can access your 0 index, your 1 index. You can also access it from the right-hand side by simply adding a negative number in there. So if I add a -1, and I run this, it helps if I actually put the list in front of it. There we go. Run. You'll see that it points to the last one in the list. So -1 is the 5. This, again, that little confusing. You can't do a -0. So -1, going backwards, it starts at 1. And if I change the -1, say to 2, you'll see it'll go to the 7. Prints the 7 out there. So we can do some very basic indexing and look at any one of these entities in the list. And then get the length of the list so we know how long our list is. Now, really common is not just to want one entity. Instead of wanting just one entity in here, let me just get rid of some of the notes here so that we can see what this looks like. I might want to access the first 4 values. So I can do print list 0, 4. And your first thought might be that we count this 0, 1, 2, 3, 4, which would be 5 entities, but we don't count the 4. So this is 0 to 3. So whenever you see this access from left to right, positive side, it's going to give us the first 4 elements. But it starts with 0. 0, 1, 2, 3, which is our 1, 4, 5, 2. And since we're starting from the beginning, you can always just leave the 0 out. And we can do something like this. And this gives us the same answer, whether you put the 0 in or leave the 0 out. It automatically assumes you're starting from the beginning of the list. Likewise, we can start from position 2 and go forward. And if you notice here, we get 5, 2, 7, 5. Position 2, if you look at this, we have 0, 1, 2. 2 points to the 5 position. So if you're going from left to right, you just say, hey, I want position 2, and you get everything to the end. And we could also put a second number in here like 4. That's just 2, 3, you get 2 values. Remember, it doesn't include the 4 on here. It does include the 2. Just like you can do indexes with negative numbers, I can now do -4. So this means that I'm starting with 0. I can leave it out. So the Python way is to leave it out. You don't need all that extra script. And it goes up to a -4. Well, where is -4? Here's 1, 2, 3, 4. So this should go up to this location, but not include it. And sure enough, we get 1, 4. So it goes up to -4. Remember, when you're reading it this way, from left to right, you don't include the -4. You include the first one, but not the second one. And you can also put the negative over on the other side and go -4. And if we run this one, now we get 5, 2, 7, 5. So we have 1, 2, 3, 4. And remember, it's on the left-hand side, so we include it. So we have 5, 2, 7, 5 coming out in the bottom. And the last really fun trick you can do, let me just take the -4 out, is I'm going to add a second colon here and a 2, and I'm going to run this. And it should print out every other one. So it goes 1, it skips 1, so it counts at 1, 2, 1, 2, and we get the 1, 5, and 7 coming out. And you can see that down here. And you can add in any of your other numbers in here, so we can start at 1 instead of at 0, and now you get 4, 2, 5. So again, we're skipping every other one, but now we're starting with the digit in the index number 1 place. Last thing to note is that these are all integers. If I put a 1.0 in and I run it, it's going to give me an error. It says I can't slice a float value. Even though it knows what 1 is, it needs to be an integer. And that's important to know if you're slicing your data into thirds. I don't know how many times I forget to do that, change it, convert it back to an integer, and it'll say, I can't slice 3.6666 or whatever it is. So remember to convert that into integers. So another thing to remember about lists, they can be mixed. So I can come in here, and instead of it being all, in this case we had all integers, I could easily put Python in here, and instead of 7, we'll do 7.4, comma 5. And if I print this out, let me just take that out of here. And by the way, this functionality of the index works identical no matter what's in your list. But we come in here and you'll see I have 1, 4, Python 2, 7.4, 5. And lists are mutable, so just like I did, just like I referenced the index, I can say list of, let's do 1, which is going to be the 4 place, equals let's do hello. And if I print my list now, you'll see down below where it comes out. It goes from 1.4 Python to 7.45 to 1 hello Python to 7.45. And because these are mutable with the lists, we can also do something like list.append, and we can append Simplilearn. And now if I print my list out and I run this, you'll see that I've added Simplilearn to the end of the list. And if I do a link to the list, it's now gone from 6 to 7. Let's just do that real quick. Print length of list. So now it's 7. So we've added one more unit to the list. So they're very mutable, very flexible use of setting up lists. And then we can also take this list. Let's do a new one. We'll call it nested. We can create nested lists. What that means is that here's my brackets to define that it's a list. And I can fill this with whatever objects I can think of. These can be anything, but we'll stick to numbers. I'll do 1, 2. And then I'm going to also create a nested list, and we'll create 2, 3, 4. So now I have a list within a list. So now we have a nested list. And if we print this, let's just print our nested list out. You'll see down below it prints it out just like I typed it. 1, 2, 2, 3, 4 is a nested inside the nested list. And then another option to append is we can also do nested extend. And we could go in here and let's create my nested loop. So I'm adding a nested loop to a nested loop. This is kind of interesting because you'll see here I have a sub list attached to the list. And I'm going to take the nested extend. I'm going to extend this on here. And if I run this, if I take this and run this, let me make sure I print the nested again. You can see how it's been transformed, and I got 1, 2, 2, 3, 4, and then it's added the 7, 8, 9 on there. Now, if I was just adding one nested list on here, I'd probably just append brackets around 7, 8, 9. But if you were adding multiple nested lists on here, you might do something. Then you want to use the extend on here. So we have 1, 2, sublist 2, 3, 4, sublist 7, 8, 9, and sublist 5, 6, 7. So I've added 2 different new nested lists onto this. So we've looked at lists. We've covered indexing of lists, we've covered appending or extending and sublists. Let's go ahead and talk about tuples. And tuples are really important. I'm amazed. When I first heard about them, I was like, why? Why have a list and why have a tuple? So the tuple is your curved brackets around, in this case we're going to do 1, 2, 3. And the most important thing to know about the tuple is I can't change it. I can't go in there and change the 1 to a 0. Now I can change tuple and have it equal something else, but I can't change the pieces of the tuple. And that's what's so important about the tuple on this. And you'll see when I print it, it also prints it with the curved brackets. So that lets me know that this is immutable. I cannot change the tuple. Now, we can access the tuple just like you did the list. I can print tuple position 1, and if I run that, it's going to print 2, because remember we start with 0, 1. I can do just the same way we did the indexing. I can do up to 1, which should print just the 1, because 0, and it doesn't include the 1. And there's our tuple comes out with 1 comma. So a little different output. You'll see this kind of notation when you're accessing slices of a tuple. And all the different functionality for indexing is the same. We can even do it in reverse. We didn't show you that on the list, but this works just as well on the list. Instead of the 2 for skipping, we can do a -1, and that just goes in reverse. So now I have a tuple of 3, 2, 1. So when I talk about it not being able to be changed, if we take and just get rid of the print for a second, and let's do this. Tuple of 1 is now going to equal 7. If I run this, it's going to throw an error because we cannot change the pieces of the tuple. I can reassign something else to TPL, my variable, but I can't change it. It's immutable. And one of the very common uses of a tuple is to use it as a key for something else. Now, we're not going to cover keys and codes in this tutorial, but imagine if you have an address to a house, and the house is 123 Main Street, and someone can just change that address. Then your house just kind of jumps all over the place. So you want that address to be unchangeable, immutable. And this is like a key code, so it's probably a key to some data. So it's a reference usually in some point, or some kind of data that needs to be set and unchanged when you set it for a tuple. And we can do, there's some other cool things we can do with a tuple. Now let's just take this one. We can do something, there's what they call packing and unpacking tuples. So just like we assign the tuple 1, 2, 3, I can also do tuple equals, we'll do 5, 6, 8, just because. And if I print tuple and we run that, it's still going to create a tuple out of it. And so we're saying, hey, this tuple is equal to these three values, whatever they are, and now this variable is equal to these three values, and automatically converts it into a tuple if you do it that way. And we can unpack our tuple. I can do a comma b comma c equals tuple, and if we print a comma b comma c, run that, you'll see we get our 5, 6, 8 right back. So we can unpack it and pack it. You see this a lot when you're doing definitions in programming, where you're packing and unpacking the data. You'll get to the point when you're doing scripting you don't really even notice or think about it till you're like, oh yeah, that is a tuple. It reminds you on that one, but it does come up a lot. And then another strange thing I can do is I can do a star list. Now in this, list is a variable, and a is also our letter A, just from right above. And I'm going to set that equal to a tuple, and let's print that out. Let's print a comma list. And if I run this, you'll see that I get 5, which is our A, and then it creates a list out of the remainder. So once I've pulled A out of the first part, I now have list in there. And I could have done A comma B comma C equals tuple. So this is straight from up above where we have A, B, C equals tuple. A comma star list just splits them up into two parts. The first part it refers to as just the value, and the second part it puts into a list, square brackets, so you can see how that's set up in there and how you can pull that information and manipulate it. And then, well, finally we'll look at set, and you can create a set s equals, and usually you denote it with the squiggly brackets, and 1, 2, 3, 4, 5. And if you look at this, if you remember, the set should not repeat any values. So if I print set and I run this, I now get 1, 3, 4, 5, and I've got rid of all my duplicate 3s. So I can only have unique values in a set. And if we're looking at this, this is also a subgroup of a tuple. So that means that if I do s of 1, and I try to change one of the members in there equals 1, so I'm trying to change position 1, which is a 3, to a 1, and I run that, it's going to give me an error. I can't change it, I can't append to it, so it's just like a tuple. I can't change these values in the set. What I can do is I can take a list, and let's just change this. We'll go list equals, we'll change these to square brackets. So now I have my standard list. And we'll do a list down here, print our list, and then I'm going to print, and we'll use the keyword set. And we're going to change this from a list to a set. And then I'll go ahead and print that out. And if I run this, you'll see that my list has all the values. But the second I convert it to a set, which is a special kind of tuple that doesn't let you repeat values, you'll see that it gets rid of all my duplicates. So now I have 1, 3, 4, 5 in there in my set. So now we've looked at a lot of different ways to store our data in different variables. We have our list variable, we had our basic variables, we had our tuple, we showed you how to do a set. Let's start doing something with this information. We'll start with arithmetic operators, the most basic ones, plus, minus, divide. Now let's just take a look and see what that looks like. And we'll need some variables to play with so we can look through the basics. And if you remember, we did a comma b equals, or b equals a comma b and all that. We can actually do a comma b equals 10 comma 5. And that's nothing more than what we already did, just a little different formatting. What I'm saying is the a equals the 10, the b equals the 5. That's all that is. And I could write that out, a equals 10, b equals 5 just as easily. And our basic arithmetic operators, you're going to see is we have a plus b. And we'll do this, control copy, put a bracket around it. So we have our a plus b set up on here, and if we run this, we should get what we expect. A plus b, 10 plus 5 equals 15. And we can do that all kinds of different ways. In fact, if we look at all the basic operators, let me just do it. No, let's keep it this way. We can take this, and we have instead of a plus b, we'll do a minus b. And let me grab that and put that over here. And let me just go down this and do them all in one shot. There we go. Paste them right in there. And most of these should be pretty familiar. The first four are your a plus b, a minus b, a times b, a divided by b. And so when we look at that, we get a plus b is 15, a minus b is 5, 10 minus 5 is 5. Multiply them, you get 50. A divided by b gives us 2.0. And now we get kind of an unusual one. We have a double/b2. What this is saying is that if there's a remainder, let's just convert it to an integer. Remember I was telling you earlier I sometimes have to slice my data into thirds. Instead of going length divided by 3, I could do length / over 3, and that gives me an integer, and it just tells me, hey, where's my first third of data in? Where's that at? But if you do that, you also want to know what the remainder is. So that's what the ampersand is a, or percentage sign. That's what the percentage sign is, a percentage sign b equals 0. And then finally you can square it. And whoops, I forgot to put that as a 2. Data science, you tend to do a lot of squaring. You do like the square means error, so it's very common to see something to the power of 2. And so you'll see that a times 2 gives you your squared value. This is actually b squared. Okay, is 25. 5 times 5 is 25. So these are your basic arithmetic operators. There's really, with the first 4, there's no surprises. You just have a surprise here when you do a double slash because it returns the integer and just drops the decimal. When you have the percentage sign, it gives you just the return value, so 5.5 comes back as 0.5. And then you have the double star is your squared, so b double star 2 is squaring your value. And we can take any of these functions and assign them. So I could do res as my variable equals a plus b, and then res now becomes equal to a plus b, which should be 15 when I run it, and sure enough, there's my 15. So now I can take a and b, and they might come in from all kinds of different areas, and set another variable that goes out to where whoever needs it, returns it to the other part of the program as res. And again, this is true whether we do a plus b, a times b, a divided by b, any of those basic functions is going to give us the set the variable res to that. Now, we can also do what they call shorthand for a lot of this. So we'll do count's the most common one. You do a count equals 0 because you want to know it runs a process, adds 1 to it, runs a process, adds 1 to it. So we could do count equals count plus 1. And then if I print count, you'll see right here we get count equals count plus 1. I get 1. 0 plus 1 is 1. I can also do, we'll just do it up here, count equals, but instead of putting the equals there, I'm going to put plus equals 1. And this means I take count, and I might as well put the count here and the plus sign. And we can run that, and you'll see it now equals 2. So I get count equals count plus 1. Count plus equals 1 is the same thing, so I've added another 1 to it, and now I have 2. And we can actually do this with anything. In any of the main, I could do count times equals, so itself times 1, and of course 1 times 1 is 1, so we'll do something a little bit more exciting like 1 times 3, and I get 3. And we could do this instead of with count, let's do a. Divide equals 2, and let's print a. And if we run that, we get 5. So I've taken a, which is 10, I've divided it by 2, a divided by 2 is 10, and again, any of these operators that we just looked at, I can now do down here. There's the integer version, we can do the percentage sign, run that, it has a 0 remainder, so that's what comes up with it. Maybe, remember I was doing thirds, if we do thirds, we can see I get a remainder of 1. If I do divide, a divided by 3, there's my 3.3333, very common, but then I can also do the double divide, and I get just my 3 out of there. So a, whatever your arithmetic operator goes here, equals 3 is the same as a equals a, whatever operator you put there in the 3. So we had our basic arithmetic operators. We want to look at relationship or relational operators. And whenever you think of relationship, think true, false. Is this true or is it false? And again, we can do our print. We'll go a comma b, just so we have it down here. Take this out, clearing my palette a little bit there. And so we have our 10, 5, and then we can do a print a is greater than b. And if you're listening closely, I said think true, false. Is a greater than b? Is 10 greater than 5? And if we run that, we get true. And if you remember what we did with arithmetic and you wonder where I'm going with this, you'll see that we have all of our basic operators. We have a is greater than b, a is less than b, a is greater than or equal to b, a is greater than or is less than or equal to b, a equals b. Notice this double equal sign. A little different there, and then we have an asterisk on the bottom. So let's go ahead and run this, and you can see down here, is a greater than b true? Is a less than b? That's false. Is a greater than or equal to b? It's still going to be true. Is a less than or equal to b? Still going to be false. And then a double equal sign. Well, because the equal sign is used in Python to set variables and to set values, whenever you do a logic where you want to know if it's equal, you have to use the double equal sign. That's very important. And of course, is A equal to B? The answer is false. Remember, double equal sign. And then if you're going to have an equals, you should have a not equals. So here's our not, which is the exclamation point. And you can see that A is not equal to B equals true. So as we go through here, we have our logical, our basic relational operators, which are logic gates on here. And we can take this up a notch. And to do this, let me just go ahead and create a little bit of different data here. And in this case, I'm going to create an A1, B1, C1 equal to 10, 20, 30. And of course, if we print those out, as you guessed it, that should be just those values individually. Let me take this, clear my palette a little bit, and run that. And you can see we get 10, 20, 30 down here. And if we pop up, this is where it kind of gets interesting, is we're going to print, we're going to use the same operators we were just using, but we're going to do C1 greater than A1. And we're going to add an extra logic in here. And C1 is greater than B1. So I'm asking, here's C1 equals 30. Is it greater than 10? And is it greater than 20? And if I run that, we get true, because that, it is. C1 is greater than A1, C1 is greater than B1. Now, what happens if we had A1 is greater than B1 and C1 is greater than B1? Well, if we run this, we're going to end up with false, because A1 is not greater than B1. But we can, instead of and, we can do or. So if I run this, we'll now get true, because C1 is still greater than B1. So there's our or value. And you could stack these. I could do A1 greater than B1 or C1 B1. You could end up with a very lengthy logic statement. At some point, you got to avoid that. You have to find another means to do that. But those are two basic ones, is and or, and then finally, not. So I can take any of these logic gates and I can change them from A1 is greater than B1 to not. A1's not greater than B1. So is A1 greater than B1? No. This would return false, but then we just reverse it with the not and it comes out as true. So let's go ahead and clear this, and we're going to look at a very complicated, I don't know if it's really complicated. We're going to touch upon what easily becomes a complicated subject, which is bitwise operators in Python. So you can imagine, let's just go back to, what is it? We had our AB 10 and 5. So let's go back there and pull that back in here. So we're going to have our two variables, AB 10 and 5, and we're going to look at bitwise operators. To understand the bitwise operator, let's go ahead and print binary of A. Go ahead and do the binary of B. And we're not going to dig too deep into this. I just want you to be aware of it for more advanced programming. And you'll see it comes out here. Here's the bit value, which is your 1010, and this would be all zeros up until there. That's what the 0B means. It's binary, and everything else on this side is 0. And this is the same thing. 5 is represented by 101. 10 is represented by 1010 in binary when you switch it over. So when we look at this binary switches, we're going to do that. We can go, let's do print A and B. So if we run this, we end up with 0. And that's kind of interesting, because how the heck do they get 0 out of that? This is 10, 10, and 101. Well, if you line this up, this one on the right-hand side lines up with the 0. So guess what? That's 0. We take this 0, we line it up with this 0, and guess what we get? We get 0. There's no and. It's not the same value. And we have 1 and 0. So we are doing a if this equals this, if this equals this, and if this equals this. We get print A, which prints out, what does it print out? 0, because none of them match. And we can do something like print A, and you use the up-down bar. And unless you do a lot of work with this, you almost always have to look it up if you're dealing with binary number or with shifts and things like that of where these decimal places are. And so we're going to do A or B. If we run that, we get 15. And if we print, let's just print this in binary so you can see what that looks like. So if we print A or B in binary, let's run that. So remember up here we got 0. I forgot to convert print. Let's try that again. Let's print this in binary. And if we print this in binary, you'll see now that it's an OR. So we have 1 or 1 equals 1. 0, 1, 0 or 1 equals 1. 1 or 0 equals 1. It gets kind of confusing there, but you can see where if either one has a 1 in its place or it then comes out as 1, and so we get 1, 1, 1, 1. And it does turn out that when you print this out, it came out as 15. So if you do a binary OR statement on these two numbers, you get 15 on there. And we can do this, we can continue this down. There are exclusive, so we can do print, and we'll do this instead of A or B, we'll do an exclusive, which is your little tilde. We can run that, and it's going to return the same thing because this is exclusively 1. So if this had been 1, 1, 1, 1, and this had been 1, 0, 1, 0, we would have seen the 1, 0, 1, 0 come through on the exclusive, where the OR returns all 1s. And if you have exclusive, you can also have 1's complement. So this would be like negating your number. So we can do, we'll just do this binary, and this is the other squiggly of A, and we run that, and we'll see that this squiggly comes out as 1011, so it reverses it. It's a little different on this because we are looking at a 1's complement on there, so it changes your logic thinking on there, and unless you do a lot of work with it, it can really tie your brain in a knot. It's kind of fun to figure out if you play with it. And then finally we have a couple more cool things you can do this. We can do print. We can do what they call a shift, and I'll go ahead and put this in binary because it's really hard to make sense of it if you're not doing binary. And we can do shift 2. This shifts it to the left. So you can see right here we've added 2 zeros on the right hand side to our A, and we have the same number and it's shifted it all to the left. And we can also shift it the other way. Shift it this way, and we can run that, and now we just shift it off, and these two just get bumped off, and we end up with the last 2 digits, the 1, 0, because we're shifting everything to the right. Whoops, I'm sorry. We dropped the 1, 0, did it backwards. Since we're shifting it to the right, we lose this 1, 0, and we end up with just this first 1, 0. And this is when you get into like a huge array of trues, false, yes, no, and you need to compare them, and you can do all kinds of cool things in here. Again, it's a very advanced logic when you're doing bitwise operators. But it's important to know they're there and understand what they are, so when it does come up, you know where to look for them. And finally, talking about logic, we'll need to go ahead and look at membership operators. Very useful thing to have. Let's just do a list equals, and we'll do 1, 2, back there. 1, 2, 3, 4, 5. So we have our basic list, and the question is, let's assign a variable x equals 2. And so let's go print x in list. And what do you think that's going to print? Is x in the list? Is 2 in there? And the answer is yes, so we get true. So it's going to print true in there. And you can remember, we can also add the not in there. Is x not in list? We run that, it equals false. And when we start looking later on here, or shortly, at our if-else lists and while lists, you'll see where this comes in handy to get these true-false statements on here. And then we have identity operator. Clear our palette, identity operator. And this is, let's do x equals 10, y equals 10, and let's print x is y. And if we run this, we get true, because remember when Python points to the memory, it stores the 10 in the same place, and so x is y. And if we change this to y equals 12, it will now give us a false, because they're no longer equal. So you could also replace this with x. I don't do a lot of x is y. It does come up, so you need to be aware of it, but it's not, usually you just do x equals y, false. But x is y, I changed it to 12, so again false. And then you can also go in here, x is not y, so is y or is not y. And it's true, it is not y. So these are all the basic functions, arithmetic functions that you find with your Python install. What we're going to cover next is what happens if it's not in there. What happens if you have some more complicated math equations you need to run? Well, at that point you got to import math. So the import, it's important to know what the import is. If we have an external module to Python, so it's not part of the basic Python code, you import that module. And math is used so much that they have it bundled with the Python install, but by default it doesn't load into your IDE, into your user face, or into the program. So when you go to use math, you have to run the import on there. And let's just take a look and see what some of the stuff that math covers. Now I did a quick Bing search and it took me to Python. This is always nice because we have the actual version here, which version of Python you're in, the documentation, Python, and then we went to the math module. And in the math module we have ceiling, we have copy the sign, fabs, factorial, floor. Ceiling and floor are kind of interesting because it's just really from an external viewpoint it's rounding up or rounding down, but there's other things that go on behind the scenes that you might use this instead. And then there's here's our basic functions, and if you scroll down, you can see it just covers all kinds of different things, like is it finite, is it infinite, is it a NaN, modify f, powers. So if we're going to do an exponential, we saw how to square a value, but if you wanted to do something to the third or the fourth, you have to import the math module to do that. And you can see here where we have exponential of 1, this is like exponential x minus 1, log x, all your log functions are in here. Square root, there's one that comes up a lot in data science, if you're going to take the square means of a value for your error. Cosine, sines, tangents, all the different trigonometric functions. All this is in the math. And really, we're not going to cover all the different things you can do in math because that's its own domain. If you're working with degrees and radians or hyperbolic functions, there's just a lot in the math module, including mathematical constant e, tau, infinite, nan, pi. There's your pi in there. So all this stuff is in your math module. And when we're in here, we can do something simple like print math pi. If I run this, it should give me the value of pi, which it does, 3.141, so on. Any of the functions in here. If you import math, you could import something like this. You could import another option. Let's say I wanted just the pi value. And we could do something like this. We could also do from math, so it tells it to go to the math module, import pi. If we do this, we don't need the math in front of it, so we're just importing the pi. And I can run this, and now you can see I have pi here. Same thing. And we can do all the functionality that you saw earlier. Let's go back to import math. And instead of pi, let's go ahead and do a variable. So we can put in x equals 9.5, and then from here, from our math, we could do, if you remember from the very top, they had the ceiling, which I said was the same as rounding it up. We could do print ceiling of x, and if I run this, it should give us 10. So ceiling is actually the nearest integer that's greater than 9.5. You could also do, again, there's like cosine, tangent, all of these functionalities are in your math module. Let's see what tangent looks like. 0.0753, there you go. And then there's a couple that I see regularly in the coding. One is power. So I could do x equals 9.5, y equals, we'll just stick to 3, and we can do x to the y, or x cubed, and we can see we get 857.375. I use the power when I'm trying to figure out how long it's going to take to run certain programs, especially when you're going through a lot of permutations. You might find yourself going, okay, I got 3 permutations, and each permutation has 3 different variations. Well, that's 3 to the 3, so if I run it once through, I can guess at the time it's going to run by doing 3 to the 3, and then I can just program it to guess what my time output is. Another one is, of course, square root. So we can do the square root of, that's another very common one, square root, especially in data science when you're computing the error. We can do the square root of x. So we can do the square root, SQRT of x. And if I run this, I'll print the square root. Again, data science, the square root means error. There's your square root. Factorials, that's another one of those things that come up. Probably not as much, but if we're doing the factorial, we'll do y this time and we run it. This is adding up all the numbers up to 3. So this is 1 plus 2 plus 3, and it equals 6. Again, those are just a few of the different mathematical functions you can do. And you can go over to Python and see the full slew of them on the website. So far we've looked at data types, storing data, math functions, so some things that you can do with the data that comes in. Let's go ahead and cover another area. We're going to go into input. And we'll look at this is a very basic way of inputting data. And more specifically, inline input. So this is not your Windows interface or Frames interface or Windows XY interface. And there is interfaces for Python, whether you're exporting it into an HTML or some other format that then feeds the data back into Python. There's a lot of different options there. But this specifically is just inline. And what that means is we need to find a way to get the data in. So we'll do name input. There's our input command. And then the first part is the prompt. This is what it's going to prompt you for. And it says enter your name. And we'll add the scoop, I like to call it, but backward slash. In this case, N, this stands for new line. That's what these two symbols next to each other is. And the backward slash is a escape key. So if you actually need to put a variable in with a backward slash, like I want enter slash your, let's do enter get your name. This will print a backward slash. And this will prompt us for our name. And if I hit enter, you'll see enter get your name. And when I click down here, type in Richard, which is my name, and hit enter, then it continues the code on there. And then we can do something with this. We can do print, and we'll do hi, comma, name. And remember with the print, this just simply prints whatever the first one is, comma, the second one, comma, and so on. And so I can now hit this in here. When I go down here, it prompts me for my name. Enter get your name. Maybe get's kind of a weird way of putting it. Hi, Richard. We'll change this from get to enter input. And we might continue on down here. So we'll go ahead and do input age. I will do age equals input. Enter your age. And we'll do that same /n. And this time, instead of printing the age, we're going to enter in an integer. This is kind of a very important thing to know when you're doing line inputs. If I run this and we print type of the age, let's just go ahead and go through this. Enter Richard, and it's going to say, hi Richard, enter your age. We won't put down my real age. We'll say I'm a young 25. It's actually significantly less than my age. And this is interesting because it takes the input and it's a string. That's what this class string means. So whenever you do an input like this, it comes in as a string. And that's important to know because if you're trying to add age to something, it's not going to come out you get an error. So I could do print age plus 5. Because age is a string, when I come in here and I just do this real quick, misspelled my name, type error. It must be string, not integer. So it's trying to add 5, which is an integer, to a string, which it can't do. So that's very important when you're coding. You start getting those kinds of errors. That's where they're coming from, is you got to make sure your two types match. And one way, you can convert it. I don't know if you remember from conversions, I can simply put integer age. We'll do integer age plus 1, just so you can see how it's different. And it will convert it to age, or to a number on here, to an integer. We enter in our name, we enter in our pretend age, and you'll see that it now is able to add 1 to that age, because I've converted it to an integer. You gotta be a little careful with this, because you might have characters in there that aren't integer, in which case it'll give you an error at that point. Let's do 2 more things with this. Let's go ahead and print with a format. So we have name and age, and let's say we'll do first formatting, and we'll put in an S in there, is second formatted word, years old. And if you remember from the formatting, we can now take this, add our ampersand at the end, or a percentage, and then we put the 2 variables, name and age, in here, and then I can go ahead and run this. And if we run this, we enter, oops, got to click down here. If we run this, I can type in my name, type in my pretend age. If you said tuple, you've got that right. So you got to remember, I'm sending it as a tuple. That's what the curved brackets do to it. So now when we run this, it should give me a nice format on here, so it looks pretty. Sometimes that's really important because people are coming in, see this all the time instead of these nice forms that come up. We used to see it where I'd do prompts like this for people coming in. And we'll see that we get an error down here because D looks for a decimal. We have 2 strings. So we could do something like this, integer age. And now if I run it, I shouldn't have any errors on there. I should come in here, 25, and there we go. Richard is 25 years old. And so we did a couple things in here. We now have our formatting. We now have string versus decimals, what the D stands for. That's pretty much any number. And make sure we give it a number. So we have a setup on there. And you would probably want to double check their input if this was for a form fill out or something like that. Although this usually, I use this for small programs where I'm testing something out and I got to put a different input in each time. I don't use them very often, but it does come up. It does come up where you might need to test something out real quick or have a line input for a very long script you're running and they just need a simple line input. And one of the last things we can do on here is we can take this and let's say instead of enter input name, how about a word? And we're going to do on this word, if you remember from before, we had our indexes for our list. Well, a word of any kind is nothing more than a string of characters, and that string is stored in a list. So I can come in here and take name, and I can say, hey, I just want the first 4 letters of your name. Maybe that's what it is. And we'll print, we'll just keep it name. Maybe you're creating a username or a reference. I've seen this where they have passwords and things like that set to the first 4 letters. I hit enter. It's going to return rich, just the first 4 letters. And that's because this index works just like it does in a list. It's the same index, because it is a list. And before we move on to the next section, one more thing I want to note about input. A equals integer. If you remember correctly, we did a conversion where if you had the number in here, 3, a character, this converts it to an integer. It gives you an error if you put A in there. We can also do this as a single line. This is very common in Python to try to bring stuff together. They call it the Python way. It just makes it a little easier to read. And so you can see right here, enter a multiple of, we'll do 5. In this case, this actually converts it. So if I go ahead and put in down here, print A, we run this, enter 5, we get 5, and if I type in the type of A, you will of course see that this is of type integer. We'll just go ahead and run this real quick. Print 5 class integer. So this is just a way of combining the conversion with the input. You can put it all in one line like this. Make it nice and compact. So what we want to cover next is the if statements. And there's like the if, the else, the elif. We're also going to start into the loops. We're going to cover the while statement, which uses the logic gate in the loop. And then we'll look at the for statement, which is just a loop without logic. And of course, there's a couple of odds and ends, break and continue, which go with the loops. So the if statement, this is where we start doing something with the data we're putting in. So you'll see here, I went ahead and did input, enter multiple of 5. And maybe we want to know if it is a multiple of 5. So if a, how can we do that? We can do a divided by 5 and get the remainder off of that. Is not equal to 0. So just a little simple logic there. This returns true false. If remember, we covered all that true false statements. So if it's not equal to 0, then it doesn't, then if it's equal to 0, it has no remainder, so it's a multiple of 5. If it's not equal to 0, it has a remainder, which means that it is then not a multiple of 5. And we can just simply have it print. And we'll just, we'll do this. We'll go a, comma, not a multiple of 5. And if I run this and I enter in, and let's just enter in 3, 3, not a multiple of 5. And if we have another piece of code down here, we'll just print this is what happens next. So we might have some more script down here. And if we run that, we enter in 5, it just goes right down to this is what happens next. And if we go back and we put in 4, you'll see that 4 comes up and says 4 is not a multiple of 5. This is what happens next. And so the if statement only runs if this is true. And it runs whatever is indented. So here's our colon, and here's our indent. Python's very big on the indents. That's how it tells what piece of code is different from the next. Other languages use different, like a semicolon for Java. If you're in HTML, you have to put a block at the beginning, at the end. So every different scripting language has its own setup. And this is how Python does it. You do an indent right there. So make sure you're very careful where your indents are. And then let's go ahead and just do enter number. And if you can do an if statement, we can also have else statement. And the else occurs, print a. So if I wanted to know if this is even or odd, we could do this. I could do if a divided by 2, the remainder of that is not equal to 0, then this is going to be what? Odd? So this is an odd number. This is an even number. Just some basic logic there. And if we run this, I can now come down here, enter in 4. It says 4 is an even number, and then this is what happens next. And we can also do this if I enter in a 5. 5, this is an odd number. So just some basic logic. So you can see right here, either it is even, either it is odd, the remainder is not equal to 2, else whatever's next. And the only other option is it's even. Now this might be good if you're just doing a simple, you have 2 choices. We can also do the elif statement. And we put that in before the else statement, elif. And then of course we have our logic here. And we'll go ahead and combine some logic. We're going to do a couple things here. Let's go back up to this. Enter a number A, copy, and enter a number. We'll have a number A, B, and C. So we'll go ahead and have 3 different choices. Take out this last line. And so the first choice we want to know is A the greatest value? So we could do A is greater than B and A is greater than C. So if A is greater than A and A is greater than B, A is the greatest number. So we have this over here, and if we have that, we can have elif. We can do, let's say B. B is greater than A, and B is greater than C. We'll go ahead and do this. We'll do a print statement, print B. B is the greatest number. And if A is not the greatest number and B is not the greatest number, that leaves one other option. So we'll go down to our else statement, and we'll have else C is the greatest number. And if we run this code, here we enter a number, we'll enter 1, 2, 3, and it says 3 is the greatest number. And of course, if we run this code again, you could do 3, 2, 1, and it gives me an error because I accidentally hit a character string there. 3 to 32, 2. So if we do this and we do 3, 2, 1, we still get 3 as the greatest number. And finally, we could put it right in the middle, and it should still pull it out. We could do 1, 3, 2, and it'll still come up with 3 as the greatest number. You can actually go take this as far as you want. So we have just here the 3 choices. You could have if, else. There are other ways to do that when you get more than here. But for basic Python, this covers most of the program you're doing with the else and the else if statement as far as the logic statements involved in there. The last thing we want to really look at is a nested if and else statement. And we can do that. We'll get rid of some of this stuff on the screen, clear our screen here. And what we can do is we can go enter your age, and we'll call the variable age up here. So we're going to enter the age, and we want to know, let's say this is, are you available for a certain discount? Maybe it's a bus fare discount, maybe it's you get a discount for a restaurant or something like that. So we have it here, we enter your age, and if let's do A is greater than 64. So if A is greater than 64, we put our colon in there, and this is actually age. Print, I will print you are eligible for senior citizen discount, and maybe we'll be a little nice, we'll make it if you're greater than 60. How about greater than or equal to 60? We're really feeling generous. So if your age is greater than or equal to 60, you get a discount. Else, we'll print you are not eligible for a discount. We'll go ahead and just run this real quick. And so if you are 66, it'll come up, you are eligible for a discount. And if you put in 40, it will say you are not eligible for a discount. And then we come along, we realize, oh, hey, we have a discount also for people who are under a certain age. We have our youth discount. So we'll go ahead and come in here and we'll say, oh, if your age is less than 18, let's do less than or equal than 18. Less than or equal to 18. Print. And then, of course, we can see you are eligible for a minor discount or youth discount. And then we need to come up here if we want to do this. If age is less than 18, since it's nested, we'll do an else here. And if I put the else down here, a couple things to notice about this list. So we have our first statement. If age is greater than or equal to 60, you're eligible for a senior citizen discount. And then we put the else. So any logic, whatever happens under this else, this is always going to go. If I move this else back out, it'll give me an error because you can't have 2 else states. And certainly you could do this as an elif statement here too. So this is kind of another way of doing an elif statement. Sometimes you want to add some, let's put a note here, sometimes you might have additional script here. So before you can do these 2 calculations, you might have to do some kind of calculation here. That's why you want to do a nested if and else statement instead of using the if, elif, and else statement. And we can see here, if I run this, enter your age. Now if you enter the age 9, you are eligible for a minor discount. And of course, what we did before, if we have somebody who's 56, you are not eligible for any discount. And of course, if you're 64 or 60 or older, you get that nice senior citizen discount. And if you were listening to earlier, no, I don't qualify for the senior citizen discount quite yet, although I do look forward to it. The next thing we want to start covering is our loops, and we have the while and for loop. And so the while loop utilizes your logic to let it know how many times to loop through. Let's go ahead and take a look and see what that script comes out as. What we can do is let's go ahead and take a word equals to, let's do Python, since that's what we're programming in. And let's do I equals 0. And let's say while I is less than or equal to 5. And since this is, we use that indent, just like we did the if-else statement, we still need that indent in the colon there. While I is less than or equal to 5, let's go ahead and print word. And then we're going to do I. If you remember correctly, we're going to increment it by 1. We can do a plus equals 1. Same as I equals I plus 1. So I plus equals 1. And if we run this, we'll come down here, and you'll see it repeats the Python, in this case 5 times. And we can even do something like this. Let's do I, comma, word. And let's run that. And you'll see we get 0, 1, 2, 3, 4, 5. One of the things always to be aware of is we did I is less than or equal to 5. If this was an actual length of the array, you would have array out of bounds, because remember, you don't want to include the length of the array because it's 0 to 4. So a lot of times, just remember, unless you actually wanted to print 0 through 5, we can do while I is less than 5, print I plus or equals 1, and then we get our 0, 1, 2, 3, 4 Python. Now, there's other ways to do a loop like this, and I'll show you in just a minute with the for loop. This just gives you an idea. Here's our true-false statements, and just like we did before, you could have if I is less than 5 or I is less than 8, which would kind of be redundant. But you could have your or and you could have a very lengthy logic gate right here, as long as it returns true or false. So we use the while because we don't know how many loops we want to go through on here. In this case, we actually set it to 5. But maybe we're building a list, and let's just go ahead and do this. We'll do a list. We'll create an empty list. Let's get an input, and we'll call it C, and it says enter 1 to add elements to list and 0 to exit loop, the while loop. We've created a variable and then an enter here. And the input, if you remember correctly, we're not converting this to an integer. So we're going to just go ahead and keep it as a character. And so we're going to say while C does not equal, and because it's a character, we got to go ahead and put the brackets around it to let it know it's going to be a string, the string of 0. So long as this doesn't equal 0, keep doing. And then we're going to do here on our while loop is we're going to have another input here. And on here, we're going to have input, enter an element to add to the list. Let's see, input, integer, this one isn't it, we'll just keep it as a straight input. I kind of like that. Keep it uniform on there. And what we can do, let me just go ahead and copy this up here. So we're going to start adding elements. And the order in which we do this is always important. You never know how your loop's going to go. I switched that around because I want to append to my list C. So whatever we enter in on the first one gets appended to the list, and then we ask for the next one. If the next one is a 0, so whatever we type in there is going to be added to the element. And the order, as I was saying, is important because if we put this after the second input, whatever you put in here is going to ignore. And if we put it before, then it's going to keep adding it in until you put 0 in. The 0, if you put this after the 0, it will still add the 0 in. So you'll end up with the 0 at the end of the list. So by putting it before this input, we're going to have both the first input going in and whatever input we add in. And to get a view of what this looks like, let's go ahead and print our list. When we run that, you'll see it comes up, it says enter 0 to quit and other to add to list. But I can add an A in, we can add a 3 in, a T. Remember, I didn't put any bounds on it, making it an integer or anything like that. And I'll put the 0. And when I put the 0, there it is, A, 3, and T. So this while loop keeps going until it hits something that says, okay, we're done, and then it just kicks it out. So it finishes the loop, comes back up here, says, is this true? If it's true, we do it again. If it's false, then we skip out of the loop. And then it continues on down below where we printed the list. Now, if you remember from earlier when we had the I plus 1 and we just looped through to print Python out 4 times, certainly there's better ways to do that instead of adding all that math in there. And we can do that. So word equals, let's do Python. So we can do that just simply by doing a for loop. For doesn't require logic. We do for. We'll do W in range 10. And let's go ahead and print W, comma, word. And if I run this, we'll see we have Python printed 10 times. Let me just take that down a notch since my screen display doesn't show up as much. So range 3. And if you remember from earlier, range does 0 to 3 but doesn't include 3. I could just as easily put 0, comma, 3 in here and I'll get the same answer. And you can also add a step on there. There's a lot of controls you can add with range. So we can print W, range of 3. And that's pretty cool. It just prints word over and over and over again. What we can also do with this is we can create a list. So I can create my list. There's our square brackets. And we could do 1, 2, let's add hello. We'll add a sublist, which is 1, 2, 3. And so we can do on this is I could do, instead of a range, I could do object in list. So for object in list, I want to print just the object. And if we run this, you'll see down here we have 1, 2, hello, and then it printed the sublist, the whole sublist in there, 1, 2, 3, because that's one object in there. So it just iterates through each entity in the list and prints it right out. What we can do next is we can kind of combine some of these. So you've seen the for loop, we have our if statements along with some different logic gates we can do. So we can do, let's do this. Let's go word equals input and let's do enter word. So we're going to get a word from you off of your keyboard. Let's do count equals 0. And we're just going to count vowels. We're going to use the loop to count the number of vowels in Word. So for I in Word, remember from before, we can iterate through each object, and when you do a string, so if we have, if our word was equal Python, we have Python. Each one of those is an object in that list. That's an actual list. So we enter the word, that's a list of letters. And so this is just going to go through and look at each one of those letters. And we're going to say, hey, if I in, and we'll give it an array. If it's A, E, I, O, U, or capital A, capital E, capital I, capital O, O, capital U, these are seen differently. They're very different characters on there. We have our colon here. This lets us know we need to indent. At this point, we know it's a vowel. So we want to go ahead and count plus equals 1. And then we just want to go down here and say print number of vowels in, let's do a little formatting. S is D. And if you remember, we got to create that little tuple at the end with all those different values. And so here is our word and our count. So let's go ahead and run this. And for the word, I'll go ahead and enter in count. And we can see the number of vowels in count is 2. And sure enough, it's got an OU in it. And if we run this again, and let's do counting, we can see that there's 3 vowels in there, OU and I. Now, when we're talking about loops, both the while loop and the for loop, and this works actually on the continue and break will work any kind of indent. So even the if statement, I could add a break partway through the if statement and it will kick it out. So that's important to know, but we want to know about break and continue and how those work. So let's go ahead and create a little script here so we can take a look at it. And break is just like you think it is. Whatever it's doing, it stops it. It breaks the flow. So let's go ahead and do this. We're going to do range 2, comma, the integer of n divided by 2 plus 1. We're going to look for prime numbers. We're going to see if we can figure out how to find a prime number. And so what we have going here is I'm going to take n, which equals 49, and to help me find the prime number, we're going to go all the way through, let's see, in range 2 to n divided by 2. We're going to add 1 to it. Now for the first part, we don't really need to add the 1, but I'm going to show you in a minute that for another piece of code we can put the 1 in, so I'm just going to leave that in there. And we're going to just divide by each of those i's. So I is equal to 2, 3, 4, 5, 6, all the way up to 25. So it's basically 2 to 25. And we want to take and we want to divide by that, but we want to know if there's a remainder. That's how we can tell if it's a prime number, because if it has no remainder, then we have a prime number. So n divided by I, the remainder of it, if that equals 0, then this is not a prime number. So we'll print this is not a prime number. And instead of this is, we'll just go ahead and do, let's just do something simple. N is not a prime number. There we go. Now, if we picked a number like 20, it'll get to 4 and print this is not a prime number. It'll get to 5, this is not a prime number. It will get to 10, this is not a prime number. It's going to print that 3 times. We don't want it to keep printing that. We want it to stop. We want to say, hey, we got an answer, it's not a prime number, break. And if we go ahead and run this, we should get 49 is not a prime number. It's divisible by 7. We do know that, the number 11 is a prime number. So if I run this, it'll just go through the code and say, okay, we're good. This is the kind of thing you might do if you have an input and you're checking the input to make sure they're valid inputs. You want to come up and say, hey, this isn't a valid input, kick it out. Or if it's a valid input, go ahead and do the process on there. And if you're going to have break, we also need to look at continue and how that works. And so let's say instead of looking for a prime number, I want to know all the different numbers that divide into the number. I want to know what it's divisible by. And so we can do that. Let's do if it's not equal to, if n divided by I is not equal to 0, I want it to continue. Else, what I want to do is I want to print, let's do our place marker. We'll do D is divisible by, this is also going to be a number, so we'll do another D for decimal. And then, of course, if you do this part, we got to have our tuple on the end. And in this case, we want to do our number n is divisible by our number I. So let's take a look and see what's going on with this code. Continue, unlike just says, hey, here we have our loop, or it could be a while statement, for statement. So here we have our loop. I get to here and it says, okay, if this remainder does not equal 0, I don't want to do anything after this. I just want to go back to the top of the loop. And so it skips this line down here. It's like an else statement right here. Else do this. So this is one way you can almost put an else statement here instead. So I can run this, and it says process finished, because 11 happens to be a prime number. We'll set it to 20, since I brought up that earlier, and we'll see that 20 is divisible by 2, it's divisible by 4, it's divisible by 5, and by 10. It just goes right down the list. And so this gives you an idea of how you can utilize the continue when you're in one of these loops to use that logic to help you get the script to do what you want it to do. The next topic we want to cover is going to be some more advanced modules. As you get more and more advanced in Python, you really are starting to look at all these great modules that are developed by third parties. One of the greatest strengths in Python is you get a module to do almost anything. And two of the modules we want to look at are arrays and Numpy. These are, in data science, they're so important for storing information and manipulating it. And the difference between an array, because remember we did lists, remember lists from before, or list, they equal within the brackets. And a lot of times you might have caught me once or twice, hopefully you didn't, but you probably did, where I called a list an array. In Python, they're not the same thing. That's very important to note, because a list is a base Python list of objects, where the array is a special module you bring in. And you got to be careful when you're talking about other programming languages. An array is what a list is in Python. So you might hear that terminology. They probably have some other programming languages. And they do have a lot of similarities. So we're going to do from array import star. So we're going to import everything we have from the array setup. That's all this means. So from our array, we're importing all the different submodules in it. You could probably just get by with import array at this point, because that would do a similar thing, but we will let you know that there is a difference there. And when we do an array, we just use the array command code, and then we can create the array inside the brackets. And just like a list, we can do all kinds of things with this as far as mix and match. But one of the nice things about array, I can also tell it has to be of a specific type. So in this array here, I'm designating these are all integers. Send to it a list of integers, 1, 2, 3, 4, 5. And if we print the type of the array, you should see it come down here and it says, okay, class array has finished. So the class is always going to be an array on here. And this particular array might designate it as integers. We can also do on our print, just like you have, like your regular array, you can access the integers by their index number. So we'll put in 2. If we print the array of index 2, we'll see that it points to 3. So it's just like a list so far. So far it has all the different setups you would as a list on here. And this includes append. So I could actually take this and I could go array append minus 10. We'll run that. Just print out the whole array. And we'll see now we have an array of type I, 1, 2, 3, 4, 5 minus 10. So we can just append just like we did. So in other words, all the functionality you have on your list, you're going to find you have with the array. We'll just go ahead and do a couple more like that so you can see what that looks like. Let's go ahead and remove 3. So if I remove the value 3 from here, you'll see 1, 2, 4, 5 minus 10. If we want to go ahead and print, you saw I printed the index the first time. We can also do an actual index minus 10 on the array. Let's go ahead and run that. And we get 4. And this is kind of interesting because if I did this with a list, I would get an error by doing the index minus 10. So we have minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it just kind of loops over until it gets to the 3. But where arrays are different than lists, and this is so important, this is what makes an array an array. We'll take this back here and just print the array on here. I can do something like this. AR equals AR times 3. And if I run this, you'll see right here, my array has now jumped. And so when I do AR times 3, the array is now 2, 4, 5 minus 10, and it repeats it 3 times. So this is one of the cool things you can do with an array on here. Now, at this point, if you're doing a lot of functionality on your array, you'll almost always end up in numbers Python. So even though there's a lot of really cool things, especially the type settings, so that you can actually have it all integers, really, in this particular module, you want Numpy, which sits on top of array. And probably the most common form you see it, you'll see import Numpy as NP. Now you can just do import Numpy, and wherever you see NP, you use Numpy. Now, if you are, you'll see when I run this, I get an error because I opened up a new project in PyCharm. That means all my modules that are added in externally aren't there. If you are working in a different IDE, you might go to the command line and do a pip install Numpy, and that will bring it in if you're using pip. There's a number of different install packages. If you're using Jupyter Notebooks under Conda or Anaconda, it's Conda install. Conda does the same thing as pip, except that it brings in all the different sub-packages. Pip's the most common one, your pip install. But we're in Python PyCharm. And so in PyCharm, we want to go up to, click on that File. Once we're on File, we want to go down to Settings. Once we're under Settings, we want to go under our Project, and then you'll see Project Interpreter. And this is really cool that we're actually in here, because you can see underneath here we're using Python 3.6. So if I had a rollout in a different version, I could go in here and add those versions in and switch them around. I just have the one on this particular machine. And I go over here to the plus sign on the right-hand side, and I click on there, and then for installing in here, we'll type in Numpy. And once I have Numpy, you'll see there's different versions of Numpy on here. Generally, you want to ignore all of those unless you're doing something special and go right to the one that's just straight Numpy. And then click on Install Package. Then PyCharm will take over. It will install the Numpy package into this particular environment. This is one of the beautiful things about using PyCharm is it keeps this environment separate from everything else. And then once it's installed, we can now go back, close out of here, out of Settings, and there's our Numpy added in there. So now it shows me what I have installed on here. This is such a great tool because I can see exactly what I'm using in this environment. And now when I run it, you'll see I don't get an error for not having the module. So you got to make sure the Numpy module is installed. And this really is, if you're doing data science, one of the bread and butter tools you need is your Numpy setup, your Numpy array. And we'll go ahead and create our first Numpy array. We'll call it AR1 equals np.array. So np for Numpy, .array is the command. Oh, let's just do 1, 2, 3. I guess I'm being a little boring as far as what I'm putting in it. And then let's go ahead and just print that and see what that looks like. Print. And this is an array made with a list. There's other ways to make an array, but we're just going to print our AR1. And we put a list in there. So we just designate a list into it, and then we print our AR1, and we see that it comes out. It looks just like a list. One of the catches is there's no commas in here. So if I wanted to go ahead and let's say take our list, and you're going to say, why is this so important? There's no commas in there. If you're doing a lot of debugging and you see this first one, you know you're either in an array or a list. If you see the next one, you know you're in Numpy. So it's just kind of a quick flag in the programming script and debugging for some of the things you can look for. Now, the Numpy array starts to take a major shift here. This is where this becomes real important as far as the setup. We'll talk about shape and sizes and matrices here in just a second. But let's go ahead and do this. We're going to create two sublists. So remember that from before, we have list 1, list 2. If I'm going to do that, I do need to put brackets around it. This is a 2D sample, and you could look at this as being one of the common things is x, y coordinates. So I might have 1, 2, 3 for x, 4, 5, 6 for y. And if we print that out, you can see as it comes down here, print our AR1, it prints it out, no commas, but you have your two different lists on here. And we can do something like this. We can print dimensions equals, and then I'm going to do AR2.inDimensions. So if we run this, you'll see it comes out with, I have it print or set up on there, and it has 2 dimensions. And that's pretty easy to see. We have dimension 1, which is a 1, 2, 3, and dimension 2, which is 4, 5, 6. Likewise, there's also size and shape. And so if I do this setup on here, we can see that we can get the size, dimensions is 2, the size is 6, just how many entities are in there. And then the shape, this is, I don't know how many times I look at the shape of these things, because you're putting it through some kind of format, and if your shapes don't match when you're doing machine learning and you're doing a fit and a train, you'll get an error. And so it's so important to double check your shape and make sure it's correct. Make sure we have a 2 by 3 matrix in this case. And then finally, just like you can do this with any of type command, we can also get the what they call D type in Numpy. So in your number array, we'll see that the type of elements is an integer 32. So it actually returns what kind of elements I have in here. And they do. They all look like integers on there. Let's go ahead and take a short detour here and just take a look at the Numpy official site. So if we go to the official Numpy site, we'll see right off the top scipy.org, which is the group behind it. It's all open source. You can actually go in here and donate to it. And it is so extensive. I'm just going to look at data types. And so data types gets its own tab, and you can see from here we were integer. There's so many specialties you can do with this, and so they cover just about every data type you can think of. There's our integer 32. So here's our integer 32 that is the standard. That's usually what it converts to if you're converting directly from Python into Numpy. But you can force it into any of these other different kind of data types on here. So it has a lot of diverse use on this. Obviously, we can't cover everything under Numpy. There's array creation, input-output with Numpy, indexing, broadcasting, byte swapping, structured arrays. Each one of these is a significantly large topic. It's its own class, if you will. You can see right here we're going to do that. We'll try to cover just a couple things so you get a little flavor of Numpy. So let's take a look at, we have our Numpy stuff going on. Let's go ahead and look at filling an array with zeros. This comes up because sometimes you want 0 as your placeholder, and so you begin your process with filling it with zeros or ones or other values. And you can simply do np.zeros. And then this is important as it needs to know the dimensions. We'll do a 2 by 2, and we'll do a d type equals, and there's our integer. So we're going to fill it as integers on here. Let's go ahead and take our z, and if we print this out and run that, you'll see that I get a nice 2 by 2 array filled with 0. So maybe I'm doing plotting. I don't know what the plots are, but I need to have it pre-filled. Yeah, a lot of test data does this. You can create your own data and make stuff up and do all kinds of things there once you have it pre-formatted. And if we fill it with zeros, we can also fill it with almost anything. So instead of zeros, we'll do a full, and let's do 2, 3, and then instead of this, let's fill it with, let's do 1. And let's run this. And when I run this, you'll see that I've created a 2 by 3 array, all filled with ones. And just like our list and everything else, we can come in here and we can access the different indexes of our Numpy array. In this case, we're going to do index 1, 2. And when I run that, we get 6. Where does 1, 2 come from? Well, remember, we count from 0. So there's 0, 1. And we count from 0, we get 0, 1, 2. And so if we do this arrangement, 1, 2 is going to be the row followed by the column. And just like any of these, we can get very complicated. We can do something like this. We'll keep this as 1. And we could also do, so we'll do 1. We have our comma, but I want to do after the comma a colon there. Then I'm going to put in another colon. And if you remember from before, that means we're going to do a step, and let's do -1. So this is look a little familiar. This is the same kind of format you got from list. And if I run this, we're going to look at the 1, so 0, 1, 4, 5, 6. I'm going to select all of them. That's what the first colon is. And then the second one says, hey, but I want to go backwards. We're going to step -1. And so we're going 6, 5, 4 on here. That's why you get the 6, 5, 4. And we could also do something like this. We could add in 2, 1. And if we run that, you'll see that I get 3, 2, 1, because it doesn't include 1. I could do up to 2, and then we get 3, 2, 1, 6, 5, 4. So now we have the first 2 in reverse, 0 and 1. And you can just play with this. Different ways to select different entities in our Numpy array. And although we can't dig into all the different aspects of a Numpy array, I did want to bring up one last thing, which is operations on a Numpy array. This is pretty cool because I can take this, and here's our Numpy array we've created. We can do something like this. We can take print array 3, and let's just add 10 to it. And this is a little different than what we've seen before. So if I run this and I add 10 to it and we run it, you'll see it adds 10 to every entity in the array. So I have 11, 12, 13, 14, 15, 16, and so on. I'm just adding 10 on there. And likewise, I could do all kinds of different values like times 10. So there it is multiplied out by times 10. There is other functionality, like you can sum it. So we can sum all the values in there. You could also select just a slice of this. So you could select, let's do the first 0 and then sum it. And so we get 6. 1 plus 2 plus 3 is 6. So there's sum, there's min, there's max. The slew of commands just goes on and on and on. There's so much you can do with the Numpy array. And some important things to note, there's also what they call transpose. And this comes in a lot when you're graphing, because you might have a graph that looks at xy. Let's go back to our 2D array, and it wants all of xy, but your array came in as all the rows. So you have 1, 4, 2, 5, 3, 6, and you need to transpose it. If I run this, you'll see that I've gone from 1, 2, 3, 4, 5, 6 to 1, 4, 2, 5, 3, 6. Tends to be the other way around. There's times when you need the individual pairs, and of course we could go back and transpose it going the other way. Of course this doesn't work because when you do this, it doesn't do it in place. You have to let it know it's in place if you're going to do that. So we'd have to do something more like AR3 equals AR transpose. Take this T out, and now we should get it where it flips it from the original values to 1, 4, 2, 5, 3, 6 and back again. So we can move the data back and forth and transpose that back and forth quite easily with this. So we touched a little bit upon the basics understanding of Numpy. It's a really powerful tool. We need to move on and look at functions. Functions are so important in Python. They're kind of programmers' bread and butter. So let's do a function. Just call this fun. And in our fun, I want it to print Simplilearn. So what I'm doing is I'm creating a function that allows me to call this piece of script whenever I want. So instead of having the loop do this, I now have the function do this. And instead of, maybe I have this function where I want to print Simplilearn at 5 different places in my program. Instead of retyping it, I can just wrap it all up in a wrapper, function wrapper. And we can simply just call this. The way you call it is you just type in the name fun, because that's the name of our function. A little confusing there for fun. Simplilearn is fun. I like that kind of combination. And if we run this, you'll see it just simply prints Simplilearn, because this function executes whatever's in this indent. And you can see right here is our def. Lets it know it's a definition, the name of our function, and then a set of brackets right here. Now, if we want to do something, it's exciting just to be able to print something. Maybe we want to add 2 numbers. And let's go ahead and do A, B. We can now put these numbers in these brackets, and this function now sees these numbers in here. And we can go ahead and print, let's just print A plus B. And I'm going to come down here and go add, and we'll do 4, 5. We'll run that. And if we run that, you see 4 plus 5 equals 9. Well, we might not want to just run it. We might want to actually have a value come out of it. And so instead, we'll do S for summation equals A plus B. And then I want to return this value. So now I can come over here and I can do, we'll just call N for number, equals add 4, 5. And if we print in, you'll see this whole process now brings it all together. So now I have my function. I'm sending it A, B. It's going to add A, B, and it's going to return the results for that. And then I get that under my N. So I set this variable equal to that, and I print N. And something I want to point out is that this return S is a tuple, and we'll talk about that again in just a minute. Or why not? We'll just go ahead and do that now. So we have our summation, and then we might have the difference. What's the difference between A minus B? Do minus B. And I'm going to leave this just as N so you can see what that looks like. But we're going to return S, D, the difference, sum and difference. And if I print it out, you'll see that it returns 9. That's our S. And D is a -1, and it's in a tuple form. So S, D returns this nice tuple. We can also, instead of doing this, I could do N1, N2, and then we could print N1, N2. And we did this earlier when we were assigning variables. It's the same thing, but instead of assigning this N1, N2 equal to whatever they are, 9, -1, we're having it return from our function. So it comes right out there, and then we can print the 2 different values. And then this is kind of an interesting thing. We can come up here and preset our values going in. And instead of A, I'm sending it 4, 5. I'm going to say A equals 1, B equals 3. Let's do this the other way around. Let's go 5. If I run this, now remember last time we sent it 4, 5, and I got 9 -1. Now I'm sending it 4, 5, and I still get the 9 -1. But if I take this out and I don't send it any values, it'll automatically default to the A equals 5 and B equals 3. And then we get our 8, 2. 5 plus 3 is 8, 5 minus 3 is 2. So we've covered a lot so far as the basic definition, sending it information, returns it as a tuple. One of the tricks you can do is a star args. They call them args and quarks. And we're going to talk a little bit about what the difference is between args and quarks. They are designated with the asterisks. So this is args. Now, I don't have to call it args. I could call it my args. That is not specific to the program. And we can just go ahead and print. I always like to do lowercase for the first letter, and then when I change names, uppercase. And that's just kind of a Python standardization for naming your different variables. And if I print my args, we can come back down here and I can do, let's just call this AK for args and quarks. Oh, spell it out. Args underscore. There we go. And so if I go down here and I go, hey, let's call my function, paste that down here, and we'll come in here and I'm going to put in 1, 2, 3, 4. It might be I don't know how many values I have going in. I just know that I have a bunch of values that are going to come in. And I know what order they're in. And so you can see right here, it takes my args, we print out my args, and I typed in 1, 2, 3, 4, and that's what comes in. And we could do something like this. We could print args of 1, because maybe that's a specific setup, and it'll print 2. 2's in the 1 place, that's our index. And if we're doing like addition, we could do something like C equals my args 0 minus, let's do addition, plus my args 1. And you can guess on here, if we return, call it A, we can come down here and do A equals args of quarks. And then if I print our A and I run this, you can see it comes up with 3, because 1 plus 2 equals 3. And it might be that you only do stuff if 3 and 4 exist. Let's just do it this way. Well, this is fine. So you can see right here that we can now send it whatever args I want, and it will do those in a list. So I could send significantly more values in here than is up here, and that's okay. And that's how your args work. Again, the asterisk. So where does quarks come in? What does KW args mean? Well, instead of my args, let's go star star. Let's go asterisk asterisk or star star my KW args. And let's just go ahead and take a look and see what these look like. Let's print them out. Grab this variable up here. And again, it's the double asterisk. This lets us know that this is a quart. And down here, where I'm calling my definition, I'm going to go ahead and change this up, and I'm going to say A equals 10 and B equals 20. And then we have return A. Let's just take the return A out for right now and just have it print it. And if I run this, you'll see it comes up with A10, B20. We haven't talked about dictionaries. We didn't cover dictionaries yet. It's a special kind of set. And the way the dictionary works is you have your index or key, and it has a value. And the index or key is immutable. You can't change it. You can delete it, you can add it, but you can't change it. And you can change the in value. And so you can see right here, we have an index of A and an index of B. And so I could also do print my quarks, and instead of doing 0, I can now do A. And we'll do addition. We'll do plus my quarks of B. Hit the wrong button there. Okay. Plus my quarks of B. And if we run this, of course, you got to make sure this is a string. The A value here is definitely a string coming in. We can do print my quarks of A plus my quarks of B. And you can see that we get 10 plus 20 equals 30. So this is just a really cool way to send information to your function and have it be able to, like, you might have all kinds of stuff in here you need to send. Once you send it, you can do all your different processes. You can also do, if you remember from before, I can do something like this. Let's do this. If A in my quarks and B in my quarks, then print my quarks of A plus my quarks of B. And you can see right here, if I change this instead of to A, I could change it to C and run it, and it'll say, hey, I've got a value of C, I've got a value of B, but because A's not in there, I'm not going to do this addition. So you start to get into some logic gates that make sure you have the data you're processing in there and what you're working on. And then one last cool thing to remember is that our definition is an object. So like any other object, and we'll talk a little bit more about objects here in a minute, I can assign it to a variable. So I can do D equals my args quarks, and then I could do D of, I'll do A equals 1, comma b equals 2. And if I run this, I'll go and run that, you'll see our first run, which we already had up here, where a C10, B20. And then you'll see I ran it again. This time it has a equals 1, b equals 2, and it sums them together as 3. So you can assign this value, you can assign this whole definition to a variable. The final thing we want to touch upon with our definition and our functions is the recursive. We've already discussed the whole reason having a definition is I can now call it from multiple times from different parts of my program, so that if I know I need to add certain numbers together, I don't have to repaste this code in every time I need that. I just access my definition in a single line. So recursive means the program, this definition calls itself. And just like the while statement, you run the risk of running an indefinite loop. And of course, if you're stuck in an indefinite loop, that will eventually crash your program you're running. And so we might have, we'll call this definition rec for recursive, and we want to take n and we want to do something with it. So we might say, hey, if n equals 1, print n and return. So when we hit the value of 1 on n, we know this recursive function's done. That's what this is doing. But if it doesn't equal 1, we might want it to print n, and then we could do something like this, return recursive of n minus 1. So let's take a look and see what's going on here. The first thing it does is it says, hey, if n equals 1, we're done with this loop, because it is a loop. It's looping in on itself. And what we want to do is we want to go ahead and print n and then just return. And then we come down here and we say, well, if it's not equal to 1, we want to print n, and then we want to run this loop again with n minus 1. So we're changing our logic gate. Here's our n. N keeps changing. So n starts off at 1 value, and we keep subtracting. And then we can just do something like this. I can do, let's do a recursive, and we'll redo with 3. And we'll run this. And I get 3, 2, 1. Why? Because each time it goes down here and it subtracts 1, that goes back into this. Then it says, okay, 3 minus 1, is it equal to 1? No. Print it out. Once we printed it out, do n minus 1, and so on. And you can see right here, we just do a simple countdown. Certainly, there's more complicated scripts you can write, but you can see how this simple recursive value works. We could use this to solve a factorial problem. Let's call this factorial def fact of n, and we'll change this down here so we call it and run it. And if you remember, factorial is simply we take a value, we want to return, call this f equals 1 for I in range, let's see, what would it be, in range of 1 comma n plus 1. Remember, it doesn't include the last one, so we have to add that extra plus 1 on there for our range. And we simply do f equals f. We can actually do this the Python way, f times equals I. So f equals f times I. And it just keeps going through and finds out what all the factorials are. And if we do this, return f, we can print our factorial of 3. There we go. And we run this, and we'll get a nice value 6. So 1 times 2 times 3 equals 6. We could also do this as a recursive problem. Just like before, we need some kind of break that says, hey, we're done. So we'd say if n equals 1, let's just return 1. If it doesn't equal 1, then what we want to do is we want to return the factorial of n minus 1. Yeah, the factorial of n minus 1 times n. That's what I want to do. So we take the value we have and we multiply it times a factorial of n minus 1. So if our value is 3, we're going to multiply that times a factorial of 2. And we take 2, we multiply that times a factorial of 1. Well, 1 is 1, so you're multiplying 1 times 2 and then back again to 3. And so if we take out this part right here, now we have the same code in factorial using recursion, and it just goes right down the list right there. And if we run this, we'll get the same value 6, just like we expected. And I want to go back a step. Let's just real quickly go back to here. There we go. For I in range of 1, f equals, we did the f times equals f, or I. So we're going through here, and this one looks pretty good. We've gone through, and it adds up the factorial. But as a recursion problem, if you remember correctly, this one just goes to the end. We know the exact answer. Danger of the recursion one, as we go back here and do a quick undo, is it's calling itself. And you can see right here if n equals 1, and then just keeps going minus 1 and minus 1, and if I run this, we get our 6. But what if the value in here is minus 3. Well, we keep subtracting. We go minus 3, minus 4, and so on. You can already see there's going to be a problem. And if I run this, it will crash the program because it gets stuck in a recursive loop. And here you go. It gives me the recursive error, maximum recursive depth exceeded in comparison. So we actually have a limit on there. So you got to be real careful with your recursive functions, but they're also really useful and handy in a lot of different scripting and computations. I hate to wrap up on an error, so I'll switch it back to 3 and run it, so we'll have our nice value of 6. What we want to talk about next, Lambda. Lambda is a very useful tool, and especially when we get into what they call mapping and reducing functions. Map and reduce itself is a Hadoop term, and there's an actual scripting code called MapReduce, but it's also a programming way of thinking. So this is a very important concept, or a number of important concepts we're going to cover with the Lambda, which means function. Lambda just is they call it the Lambda function. And how and why it works and how it's used. What we're going to do is we're going to take our add function from before. We had add AB, a very simple function to do. We have s equals a plus b return. If I run this, it'll add the 10 plus 20 on there. 30, just like you would expect it from our previous definitions. The Lambda function, or its basis, is it actually does all of this in one line of code. So that's the first thing we're going to start with, is our very basic Lambda function. L equals Lambda. There's our keyword Lambda, meaning it's a function. A comma B, and we get A plus B. And so when you see this, our Lambda function, I can print L, and then we can do 10, 20. This does exactly what we just did with the add function. It takes the 10 and the 20, it comes across as a tuple. There's our tuple being sent in. The tuple is AB, and then it simply returns A plus B, whatever's on the right-hand side. So the Lambda is a simple function. Now we can get really complicated by using a function for the function, but you can just put your simple function here, A plus B, L equals Lambda, A comma B, colon, A plus B, and we get our nice print L for Lambda 1020. We can also do some kind of filtering in here. So let's create ourselves a list. Here's a list of letters. And let's say I want to take this list and I want to filter it out. So we'll give it a variable here for our Lambda. We'll just use X. X is very commonly used in Lambda. And then we'll put over here X in. And let's say, if you remember from before when we did the vowels, we had our A, E, I, O, U. And if we run this and I go ahead and print L, pop that back in there and run. Forgot we were doing a filter function. I forgot the whole of it. We're going to do a list, and we're going to do this list of a filter. So we'll need brackets for the list. I'll have my filter, and then I'll need brackets for the filter, what's going into the filter. And the filter comes in here. We're going to put the Lambda in there. So let's break this down. I'm creating a list. From that list, I'm filtering out, and I'm going to use the Lambda function. And the Lambda function says, hey, for each entity in this list, I want to know if X is in AEIOU. And if it is in AEIOU, then at that point, I want to go ahead and add it to my list. And so here we go, we're adding it on to the LST, over filtering the LST, and we're returning the value to go into this list. What you can do is you could imagine that instead of this being a list of these, it might be a row in your database you're processing. So you have a lot of data coming in. And you can see right here, it filters it out, it gets rid of the B and the F, and we end up with our AEOA. It filters it out. So imagine that you're sending it a row in your database. So for each row, we want to know what the Lambda is, and it processes each character in this data. This could easily be an array or columns. You know, from your row, we might have column A, name, first name, last name, address, and you want to know which one of these is part of something else. So we've covered filter. What I want to cover next is mapping. And a lot of times when I work with filters and maps, and I'm working with data, the terminology map, when you're thinking map, is everything you can do to one line or one row in your database. You don't need all the other rows to look at it. So mapping is another tool, and the actual use of map with Lambda, we'll do a result equals map Lambda, and then we're going to take each character in there and we're going to just go we're going to convert it to its ASCII code, and we're going to add 1 to it. So we're just going to adjust it to each one. And so I forgot and took out my actual list. Of course, PyCharm already remembers it unless I restart the PyCharm environment. So it'd still work if I ran it. So we have our list A, B, E, F, O, A. And then we're going to get a result. Let's go ahead and print the result and run it. and you can see right here, result, and we'll convert it into a list. And so when we print the result, we get B, C, F, G, P, B. I'm guessing, A, the next one up would be B, B, the next one up would be C, E, the next one up would be F, and so on. And again, when we're talking about maps, the mapping part of a program, it's whatever you can do on one line of data. And I bring that up, and I keep saying that over and over and over again, because when you touch upon data processing, and especially big data, this is how we're able to cover tera and terabytes of data, is we process one row at a time. And that's the mapping. They call that is literally the mapping. We are mapping something. If I look at this row of data, I don't need to know anything else about the database other than this row of data. And that's how I'm going to map it. And if you're going to map something, you need to go ahead and reduce it, because if you have a ton of different rows in a database or whatever you're working with, in this case we're just working with characters in a list, you want to reduce it to something everybody can read, something you can process at a glance. We do need to go ahead and import reduce, so we'll do that from the function tools, import reduce. That makes it much more legible instead of doing functools.reduce. And then we'll do our results equals reduce lambda x of y, x plus y of our list. And all we're saying here is for each element that we look at, we're going to divide this up, and then we're just going to keep adding it on to our list. And then if we print out the result, we run it, you'll see we end up with A, B, E, F, O, A. And that's from the original list. Remember, this lambda result is not fed into here. This is the list that's being fed into here. In fact, let's go ahead and remove the map. I'm going to keep the map up there and reduce. So we mapped it, and then we take, so we're processing each individual character in our map. We're processing each individual character in this list, changing it, tacking it onto the list, so it returns the differences, and then we're going to bring them all together. So we're doing a reduction, reducing it into one string down here. So we've covered a lot. We've had our functions. We looked at our lambda. The next thing we want to look at is modules. And we've already been looking at that without even knowing it. And we'll start with, I'm going to call this, I renamed this one mod1.py. This is stuff we already did earlier. So we had our prime of A, our even number of A, def prime of A equals for I in range 2, comma A. If the remainder of A divided by I equals 0, print number is not prime, return number is prime. And then we also did even, print number is even, print number is odd. So this is something we did earlier. We created these definitions to let us know whether it's even or odd. I've changed the name to mod1.py, and this is going to be saved in the same folder as our Scratch. So this script that I'm going to write in here is in the same folder. You can also put it in your library. So if you have your environment and you have all your library folders, which has all the other default Python, including the modules we imported, this will access either one. And what we can simply do on this is we can now import our mod1. And so we can do from mod1 import everything. So that's going to import our two definitions. It's going to import prime and it's going to import even. And so anything we do in here can now access that. So we can now do n equals integer. Let's do an enter input and enter number. So we're going to have it input a number, and it's going to force it to be an integer. So now we have our n, and we'll simply do print. And let's take a look over here. We had from our module, we had print prime of A or even of A. Those are our two options on there. That's what we brought in. So I can do print prime, and we're going to send n back there. And I can also do print, or actually there's no print because there's no return statement. So it's just prime of n and even of n. So those are the two things we imported. And if we run that, it's going to ask me to enter a number. We'll enter in 3 or 23 in this case, and you'll say number is prime, number is odd. So 23 is a prime number, and it's also an odd number. Is it even or odd? This can be very complicated because you could also do, add a select in here, run this if I have a selection of A or B or whatever. But at this point, you're now writing modules for your script. And you can see how you can easily organize a very lengthy program by having your different modules built outside of what you're working on. So you don't have this huge length of like hundreds of lines of code to read through. You only have the little piece you're working on. And you can share these modules. That way, if you're working as a group, just like we imported math, or Numpy is NP, we can now share these modules with other people who can then utilize them for their projects. Let's go ahead and close out of this and clear up my area I'm working with. And we're going to jump into the next big topic. That is not meaning that I just knocked my coffee over and spilled it all over my desk, but object-oriented programming. And we're going to start with the theory, because there's a lot of theory behind OOPS. It's been around since the 90s, very central to just about any programming language out there. And earlier when I pointed out that your functions, when we do the def statement, def whatever your function name is, that those are objects. We can actually set them to variables. And so object-oriented programming is what this is all centered on. We have an object. Everything in Python is an object if you look at it. Programming paradigm that focuses on objects. Every instance in Python is an object. So like I just said, everything you do in Python, you have an object you're looking at. An object has attributes, so we have data that's describing the object, and it has behavior, methods on the attributes. These are your definitions, your functions. And your attributes are your list, your arrays, your Numpy array, your variables. All those are attributes. And so, for example, if we have a BMW, I don't drive a BMW myself. I actually have a beat-up pickup truck. Given where I live, I would prefer my pickup truck to the BMW, but if I live someplace else, I would definitely like a nice BMW to drive around. So for an example, you have year, manufacturer, maximum speed. Those are all attributes of your BMW. And for behavior, you might display the speed, because the speed's always changing. So there you go. Those are all behavior. As you accelerate, the amount of gas going into the engine changes. As you push on the brake, you're pushing on the brake is a behavior and is changing the speed of the car. So we define a class. A class is a collection of similar objects. So, for example, a car, we have BMW, we have Ford, we have an Audi. The inheritance mechanism for a new class to use the features of another class. So we have a number of different things. Inheritance, we might have our class, which is vehicles, and then under vehicles we might have cars. And cars inherits all the different stuff from vehicles. So we have inheritance, so you can create a class from another class. The feature preventing data from direct access is called encapsulation. So when we have our object programming, we have integers. We looked at integers. You can't actually access integer. You assign a variable that has all the different features and functions of an integer, but you don't access the actual integer object. You can, but generally you don't. You have it encapsulated so that it's never altered. And polymorphism is a feature of using the same function in multiple ways. So you can think of this in our example of vehicles and cars. We might also have vehicles and bicycles. Well, bicycles accelerate very different than a car does. A car, you step on the gas. A bicycle, you step on the pedal. Both of them have a similar acceleration. You want to polymorph that function so that it works the same for both of those, but it does something very different. So let's go ahead and create our class, and we'll call it car. We have our semicolon here, which says that whatever comes after this is indented as part of the class car. Now, there's some things we're leaving out here. You'll almost always see brackets and variables in there. We'll look at that in just a moment. Let's just start with the class car. And we might have car type. Let's give it an attribute. And this particular attribute is a car type. And we'll set it equal to manual. And this is a global variable we've set up on here that's used throughout the setup, throughout the class car. And then we want to create a def. And this is a very special definition. Remember, that's a function for def. And we call it init. It stands for initialize, and we put a double underscore before it and a double underscore after it. What that means is when I create this class, an instance of the class, not the class itself, but I create this instance of this class. I create a variable equal to car. This initializes it, and self means that it's referring to itself. Whenever you see self in the class, you're referring to that instance. And we'll look at that a little bit more closer in just a minute, so hopefully if you're confused, we'll be able to help you with that. We'll go ahead and pass it a couple variables. Speed. So when we initiate class, we're going to pass it year and speed, and then self is just part of what's passed into the definition. And we'll go ahead and do self.year equals year, and self.speed equals speed. So up here we have a global variable, and down here we have an instance feature. I use variable and feature kind of interchangeably, but certainly feature is probably the more appropriate word, but they are variables also. Either way, they're the same thing. And then let's go ahead and create a what's called a static method. and you set it that by doing the @ symbol here, and we'll call it static method. This is a command. It lets us know that this is not specific to an object or the class's variable. So this is independent of our specific initiation. And with this, we're going to do welcome, and we'll just have it do a print down here. We'll go print, welcome to the car showroom. Kind of fun there. So here's our, oops, I forgot to put the def in front of welcome. This is tabbed in. So when we do this, when I have our instance, this never changes. It's a static method. It's always going to do the same thing. It doesn't matter where it's coming from. It doesn't need to access any other information in any other features in the class car or in whatever initiated variable I have. And then we'll do something a little bit more traditional. Def get speed. It automatically does the self. And in this case, we're just going to do print maximum speed is self.speed. Now remember, we initiated it. So here's our self.speed. Self means it's the instance we're creating. It's not the actual class, but the instance. And we're going to print that out. And so let's take a look at that and just see how this all comes together. I did forget one piece of the puzzle. Just like we have a static method, I'm going to do this up here, we also have what's called class specific. So when you have a class specific method, you denote that with class method. Now remember, the static method doesn't care anything about what's in the class. It doesn't care about the initiation. It has all the information it needs. With the class method, we need to go ahead and have information that's class specific. And we did that up here when I did class and I did car type equals manual. So that's the feature that we can access underneath this title. And we'll create a definition here, and we'll call this type. We'll just do CLS because it's a class method. That's what the CLS stands for. And then we're going to do print. We're in a nice showroom, and we say these cars are, comma, CLS.car type. So the CLS just refers to the class. Class are variables without the self in front. So when I have a class or a feature underneath class, any instance I create is going to have car type equals manual. Where when I initiate it and I have self, any feature like self.year, self.speed is going to be just that instance has that feature and whatever value we put into it. And then we have a static method which only accesses the static method. It doesn't have any other information coming into it from either the class or external. And then you can see here we have type class, denoted by CLS, and we can print the class type. And then we have the self. There's our self, our most basic definition, get speed. And the way this works is we have our let's do our, here's our BMW. So our BMW equals, make sure there's no spaces in front of it. It's going to equal car, and we have our car class back up here. Yeah, I did it all lowercase. A lot of times the classes you want to start with a capital letter. You don't have to, but that just is like a kind of a programmer standard on there. So you can remember that it is a class versus a variable, which we start with lowercase. And if you go up here to initial, we have self, which it automatically sends because this is a part of the car, and then we have year and speed. And so we want to go ahead and send those in there. We're going to do 2018, and we'll say it has a maximum speed of 155. I don't usually, living where I do, I don't go over 75 or 80 at the tops due to the particular laws we have. And we'll do a Ford, and this particular Ford on their showroom, what, a 2016. And maybe our Ford has a maximum speed of 140. So now we've created two instances. And if I do bmw.getSpeed, you'll see here that it doesn't, the self, which I put in here, isn't needed because it already pulls the self in. That is the instance. It's saying the BMW, which I called it, is pulling in BMW on here. And all the features with self are pulled into it also. So if I run this, you'll see down here that it pulls up the speed. It says maximum speed is 155 for our BMW. And let's say we want to know about the Ford. Maybe we'll do Ford get speed, and we run this, and the maximum speed for the Ford is 140. And of course we're looking at the little ticker tape of the car, and along comes the guy who says, hey, do you want to buy a car? And we'll do the car welcome. And if we run that, it says, messed up on this because it's a capital C. There we go. And we do the car welcome, and it says, welcome to the car showroom. Maximum speed is 140 on the car you're looking at. Our salesman's come up and approached us. And then finally, we might be looking around the showroom and saying, hey, what kind of showroom is this? What are you guys showing to me? We can do car type. We see that it comes up, these cars, typo there. These cars are, and then it looks at the car type and says manual. So you're in the manual car showroom. Now, this is all great. You have your class car. Let me go ahead and just get rid of some of this stuff. Take it back a notch, clean it up, take out, keep our BMW and Ford down there. And so with our class car, we now have under there an init. We'll keep the init where we put in the year and the speed and we set that. I've taken out my static method, but I do want to add in, let's go back and put the get speed back in, self. Get speed, and we'll just print like we had before, maximum speed. And because we put it in as for the instance, we'll do self.speed. That's how we reference it there. So right now we have our basic class car, and that looks pretty good. But what if we were talking about, remember we had like these models are all standard, these models are all whatever. What if I want to have a class sedan? So we're looking at just sedans. But I wanted to have all the features of the car. I don't want to have to do a economy, a sedan, a four-wheel drive. I don't want to redo all of the work I do in car because the get speed is going to be the same. The year and everything else is going to be the same. What I can do is we can do an inheritance. And that means when I do a class sedan of car, this inherit everything from car. So everything I have above in car is inherited. So any instance I create of sedan uses all the values in car. And we can change some things on here, but let me just show you how this works to begin with. Instead of doing, I can do this part right here. Let me just do bmw.getSpeed. So I still have my car class. So if I run this, you will see indent error because I forgot. I created this here. Let's go. Pass is just a fancy way of putting a placeholder here saying the code is here, but don't do anything. Select process, maximum speed is 155. And what happens instead of a car, we do a sedan and we run this, I still get maximum speed is 155. Well, sedan doesn't have that in there, but sedan inherited everything from car. So when we look at this, I have maximum speed equals self.speed. And the initialization is the same, self.year, self.speed on there. Now, we can also do something like this with sedan. I can copy all this over. Generally, you don't just do a pass here. At the very least, you need your init file in this. And so here's my initialization. And so with sedan, we're going to do something like this. I'm going to go super.init year, speed. And what I'm telling it is it comes in and it says, okay, I'm initializing a sedan. This is my initialization code. But we're going to go to the class that this inherited from, which is our car, and we're going to do the init there. This basically comes up here and says, okay, this is our init. This is how we're going to initialize this. But in addition to that, what I want to do is I also want to do something like this. Print this is a sedan. And so now when I run this, our BMW initializes as a sedan. It does the super, so it uses all of the init code underneath our class car. And then in addition to that is whatever I want to do. In this case, I want to just print this is a sedan. So you can see it prints this is a sedan. And then when I run get speed, it still utilizes that from the original class. So now I also have the speed and the initialization all under my original class car. I'm not recreating it, retyping it, copying it down there. And just like we have defs appear under class, we might have certain definitions which are very specific to the sedan. So maybe we have open trunk. So we'll put that in there. There's our definition for open trunk. And all it does is print open trunk. And so I can do bmw.open trunk. And if I run this, my BMW now can open the trunk. So now it has additional functionality that cars doesn't. We can see this if I do Ford.open trunk. And if you guessed it, it'd give us a error. You're correct. Car doesn't have an open trunk. I'm sorry, it's an error. This Ford, maybe it's a Ford truck, doesn't have a trunk, so it can't open it. So this is only if it's a sedan does it have open trunk underneath of it. And being able to add new definitions is our polymorphism. We can polymorph our class to do things the original class couldn't do. And we can go ahead, we could take this, let's change this up a little bit here. We'll initialize this with name, and then self.name equals name. And instead of setting the speeds here, we'll just say that this particular individual car, maximum speed of 150 for for get speed. And we'll do the same thing down here. We'll have our, instead of a sedan, let's do this. Let's just take this completely out of here. We'll take our sedan, and the sedan will have a speed of 150. But instead of a sedan, that works. We'll just do sedan. And then maybe we'll also have another one that is an SUV. And so our SUV class, they all have a maximum speed of 120. Name this SUV. And so now that we have these two classes, they're both inheriting from cars. So when we send something to them, we're going to send name, self.name, and then we have def get speed, which is going to return 150. Class SUV, maximum speed is 120. So we're storing the name underneath each instance of it, and then we're also going to get a different speed each time. Let's do a list. We'll do a car list. Here's our list of cars. There's our brackets for our list, and then I'm going to do something kind of fun here. Here's a sedan. Now, the sedan is the class. So that's an object. So I can make a list of that object. And in that particular object, we're going to give it a name. And the name of this one is going to be, it's a Camry, very common car out there. And then I'm going to create a second object, and it's going to be an SUV class. Now remember, we also did variables as definitions. Certainly you can put anything that's an object into a variable. So these are a list of classes on here with their calls. And the SUV, we're going to do, I guess, Scorpio. I'm not too familiar with the Scorpio car, but I guess it's one of the common SUVs in certain areas. So now I have a list of two classes, and these classes are both initialized, the first one with Camry and with Scorpio. And from before, we can do for car and car list. So we're going to do each car, and then we're just going to do something simple like print, in this case, car.name. And kind of a fun one, we'll add the plus sign in, and the brackets, and the colon, and give me just a second to put this together, comma end equals double brackets. This is basically, we're telling it, don't print a new line. I want to print the car followed by car.accelerate. So remember we did get speed, so we'll stick with get speed. Control copy. Get speed. Put in our double brackets. I'm just going to add a space up here and here. Oops, actually it goes at the beginning. So if I run this, it should go all the way through this list. Here's our for loop. Remember this, how we talked about iterating through a list of objects. There's our car list. And as we go through, we see Scorpio. We have our Camry. Camry is maximum speed 150. Scorpio, maximum speed 120. So we put together a nice set of polymorphism of classes. We polymorphed our car class into a sedan and into an SUV, so they each print out a very different thing or have a very different get speed functionality. But they both inherit the initial def from car. We're going to take on 7 parts or 7 code challenges that you can do to take all the basics we've covered so far in Python and see how to apply them. And we'll start with part 1. Part 1, we want to go ahead and see if we can print the number of occurrences of each character in a string. And this would be a good time to pause the video so you can actually try to solve it on your own before we go ahead and give you the solution we came up with. Now remember, there's always multiple solutions to any of these challenges. So if you come up with a different one, that's great. It just means you're thinking on there. The first thing we want to do is we want to go ahead and get an input. So we want to go ahead and pull up an input for our word that we're going to type in. And then we're looking for the number of characters in a string. So we need some way to track it. And we have what we call a dictionary. Now if you remember, we briefly touched upon the dictionary. A dictionary is denoted with 2 brackets. And it comes in the form of a key. So you'll have your key code. And then that key code is set to a value. So the value can change, the key code cannot. And if we had brackets around this, could initiate it if you already know your initial keys and values with something that looks like this. And we can also, here's our D, assign them as we go. And so we'd have our key, and then this would equal our value. And what's nice about these 2 setups is that we have a key code which could represent our characters, and then we have the value which is going to represent the count. Hopefully you remember map reduce. We're thinking map and reduce. This is such a common question that comes up in map and reduce. So we're going to map all our characters out and then count them and reduce that to, in a huge map reduce program, you would actually do each document have a summation, and then that would be sent and brought together and then reduced to just a single representation of it. So we're doing kind of the end part where we're just reducing this word. So here we have our dictionary, and then we want to go ahead and do a for I loop, for I and S. So our input is S, and this will iterate over each character in the string. And the next thing we want to know is, do do we already have D in our dictionary? In this case, we're looking at each of our i's, so if I in D. So if it's already in there, then we can simply do this. We can simply do D of I, and then you can do the plus equals, and then of course we're just adding 1 to it because we're incrementing it by 1. Now if it doesn't exist in the dictionary and you try to do that, you'll get an error. It'll say no key value there. So now we have to do a thing where if I is not in D, we do simply D of I, and we initialize it with 1. Keep it simple. And then finally, we've got all our different things. We can just print D. And if I run this, let's go ahead and take that and run it. Comes up, says enter a string, and we'll do hello. I'll hit enter, and you'll see I have H, capital H equals 1, lowercase e equals 1, L equals 2, there's 2 L's, and O equals 1. You can also, if you're trying to look at it a little bit clearer, you could do for key in D, we could do something like this. Print D of key, and you got to remember it doesn't actually print the key unless you tell it to. So here's the key and the D of key. So I can also do it this way. See if we can pick a better word on here. You can actually do a full phrase in here. So welcome to Python. And hit enter, and you'll see that we have W1, E has 2, L has 1, C1, O3, M1, there's 2 spaces, T is 2, P is 1, Y is 1, H, and so on. So this is a very simple set of loops, but it covers a lot of interesting key points that you'll use throughout any kind of big data or map and reduce program. So let's move to part 2 or challenge 2. Let me just clear my palette so we have a nice palette. And what we're going to do for part 2 is we're going to insert an element at the kth position of a list. And again, pause it if you need to. Let's go ahead and create our list. And in this case, we're going to do just a standard list. We'll do some mixed elements. We'll have like 23. It looks like they sent me an example of the list. Let me just grab that. So let's do 23. Hey, 89 Python. So we have a nice list there with 1, 2, 3, 4, 5 objects, or 0 through 4 if you're thinking indexing. And let's go ahead and do this. Let's just print the original list, comma list. And then we need our input, n equals input, and I guess we need to put where we're going to enter it at. So it says input, and let's do enter an index between, let's see, we can do this a couple different ways, but let's say we do 0, which would put it at the beginning, and then at the end. How would you get to know the end? Well, we could do this, plus string of length, in this case length of list. And remember, we don't want it to type in the actual, well, I guess they could type in the actual end. So it could be 0 or it could be the very end of the list. So this end should give us a nice input. And then let's have an object, or we'll just call it K. And actually, let's put this above. Sometimes it's nice to put these in a different order. K equals input. Let's go ahead and have it enter an element. And so this will automatically be a string that we enter here. I'm going to go ahead and just add a space there so it stays on the same line. If you have a larger screen, this might look better if it goes down a line. But in this case, I want to go ahead and just keep that in the same line. And we'll do this on here. I'll do plus and add a space. And this will be our element n and k for the actual integer. And we want to make sure this stays as an integer. So let's go ahead and take this whole thing and add integer at the beginning. It's for our index, and an integer at the end. So now we have our input. We're going to add an element. In this case, it's going to always be a string, unless we want to try to convert it. And then we're going to enter in where it's going to go. And so how do we get there? How do we put that in that list? And so there is actually a number of ways. You can actually do an insert. But let's say we don't have the list insert command. Make it a little hard on us. Let's go ahead and do this. Let's go ahead and do a list append. And we're going to append, in this case, k. That's the entity we entered in here. So if we pretend not to do the list insert and we have the append, we can append our value onto the end of our list. And what we're going to do, and again, there's like so many different solutions for this. I mean, if I was just doing an insert into my list, I would just do an insert. But let's say sometimes you have to do, other than finding out the spot on there, you might be comparing the values or doing something else going on. So what we can do is we can go for I in range 0, length of list. So we're going to create an integer that comes in here and just starts at the 0 index, so I for index, and just pages through all of our objects in the list. And what we want to know is if I is greater than, and we had our k value. Now if you did, like I did up here, 0, you could also do k value equals 1. So this gets a little tricky on your input if you're talking about your end client. Do they know to start 0 as place 0, or do they start with place 1? So that might change your coding and how you put this together. Those are things you'd want to think about. And we're going to do temp equals list of I. So we go ahead and we look at our list and we say, okay, I'm going to pull this object off. I'll create a temp here. List of I equals n. And we're going to swap in our n value. And then we'll do n equals temp. So let's take a look at this. I have if I is greater than k, and since we're starting with 0, we're going to do I is greater than or equal to k. That's just because we're starting with a 0 instead of 1. And we go ahead and create a temp variable that goes to that pointer. List of I then equals n. That's our last element. In this case, it's the one we entered. And then we set n equal to temp. So we take this and we take whatever's in that position, we put it in temp, and then we just go all the way through. And what happens is it will just keep replacing that value all the way to the end. And let's go ahead and see what that looks like. Before we do this, I guess we have to print out an answer. So we'll come down here and we'll go print and our updated list, comma, and this is just list. Let's go ahead and run this. And we'll go down here and let's enter in hello. And I always like to do the extremes. We have 0 and 5. So let's go into 0 and enter. And we have our list, which is original 23 all the way to Python. And now it says hello and puts it right at the beginning. And if you're going to do that, you should also test out the end of the list. So what happens if I put in 5? And then it comes up and you see it puts hello at the end. What happens if we put in 4? Double check. Here we go, 4, and it comes up on place number 4. And I'll do one more test on this, just because I really don't like things going out the door unless I know they work. And we'll put in 1, and you'll see here 0, 1, 2, 3, and so on, and there's our hello. And you can see here we had a nice setup on that. We have our input, and we just go through. It's really important to note that we're iterating through each value, and we're seeing if something important is going to need to change that value. This could be almost anything. This could be that you need to alter, not only insert the value, but maybe increment everything past it with +1 or something. There's all kinds of things that can come up, little weird logic that you wouldn't think of until you start messing with it. Challenge or part 3. Check if the substring is present in a string without using the find method. I remember back in the 90s, this was central to all of your programming, was to do all these little things. Now, of course, they have find built into the functionality. So string, we need to have our input. We're going to input a string, and we're going to input a substring, and we'll call them st for string and sub for substring. And I'm going to jump ahead a little bit here and then come back because we want to look at something. Let's do count equals 0, and then we're going to do our loop for I in range 0. We want to start with position 0. And then we want to go to what? That's where the question comes in. Well, we could do the length of the string. Now, there's a problem with this, and that is that the substring might be 5 letters long. So if I go to the length of the string, I'm actually comparing the substring to something that isn't even there. So I'm going past the end of the string that's not really worth doing. So how do we figure out that number? Well, we can do L equals length of our substring. So now we have a value for how long the substring is. And we simply take the 0 to length of string minus L, and then we want to add 1 on there. So remember that this length, it goes exactly to that length without including it. So we have to add the +1 in there to include the very end of that. So 0 to the length of the string. So the next question is, how do we know we have it? Well, if our substring equals string, and we want to start from position I, and we want to go to I plus L, the length of the substring. So if they're equal, we'll print count plus equals 1, our increment of 1, and we'll do print substring. Here's our placeholder, S for a string found at position, and then here's our placeholder for a number, or D in this case. And we'll go ahead and give it just a space off of here. Oh, no, that's fine. We don't need a space on that. And then we have our ampersand or percent sign and our tuple. So here's our tuple. We want sub comma I. So that'll put that right in there. This will tell us that it's in there. Each time it finds a substring, we're counting it. And then we print it out that it's part of it. A little redundant because you'll just print out the same thing over and over again. And then we can do if count equals 0. We can print substring not found. And of course an else statement, else print, and we'll do substring, here's our place marker again, S found, another placeholder, D times. And then we can, if you're going to do your placeholders, of course you have to do your tuple at the end, and we have our sub, comma, in this case count. So let's see what that looks like when it runs. Oh, before we do that, let's just walk through it. So let's take a walk through what we just did. So we have for I equals range, we had to kind of fiddle a little bit with the length to make sure we got all the way to the end, but we didn't go past it for finding our sub in the range of the string. Simple if statement says, hey, it's here, count plus equals 1. Let's go ahead and print our substring found. This will be very repetitive, so I don't even really know, wouldn't normally put this in here just to keep printing it. And then it says if count equals 0, we found none, print substring not found. And else, substring s found d times with our count. So let's go ahead and run this. And here it goes. Enter our string. Welcome to Simplilearn. I'm going to hit enter, and we're going to look for the, let's go 2. And it gave me an error. So what happened here? And I, of course, get an error. Hopefully you caught this error when I was putting it together. This should be a colon, not a comma. This is a straight list. So that's why you got to remember what array you're working in. And it does happen. And we'll go ahead and run this again. And we'll do welcome to Simplilearn. Type in our 2. And it comes up and says substring 2 found 1 times. Substring found at position 8. So now we know what position it's at, and we also have how many times it was found. And since I was just talking about Numpy arrays, let's do challenge or part 4. Find the index for the nth repetition of a number in a Numpy array. So let's go ahead and import our Numpy as NP. You'll see that very standard. And I went ahead and created an array, or our team in the back did. So we are going to go ahead and create our variable AR set to a Numpy array, and it's just 1, 2, 4, 1, 23, 1, 2, 3, 4. So it's kind of a random set of numbers on here. And let's see how we can build this. And at this point, you should be trying to think about how to do it yourself. And let's go ahead, and I'll just paste this in here. We're going to print the original array just so you can double check it in our output. And we're going to do our input. Num equals an integer, and then give a value for the number for your input. So we'll have our num we're going to look for. And let's do this. If num in r. So the first thing we want to know is even is in there. There's always a chance you might not even have that number in there. Initiating or doing initial case. So if we're looking for kind of the base case of do we want to even do anything if it's not in there. So if number in AR. First thing you want to do is check. Otherwise it's not worth processing. And then let's do this. So we want to ask the question, what is the index for the nth repetition? So we got to find out what repetition the user wants. And we'll go ahead and create another input in, give a value for in, which is our repetition or repeat. So give a value for in or the repeat on here. Now at this point, there's so many different ways to solve this. We could iterate through, but we're going to create, and you'll hear the term mask. Let me just type that out for you, where you're masking something. Masking means that we create a series of values. In this case, we're going to create a bunch of 1s, and we're going to say it equals NP. So here's our Numpy array where our input array equals our number. So this is going to return a Numpy array of either 1s or 0s. And then we can actually test it and see what's in there. Now there's other ways. We could just iterate through the Numpy array. Usually when you're working with Numpy arrays, you try not to iterate across them. The whole purpose of the Numpy array is to let it leverage the back-end code so you're not wasting as much resources. And you know what? Let's go ahead and print 1 out just so you can see what that looks like, what this masking does. So NP where r equals number. And let's go ahead and run that. And here's our setup. Let's enter in the number 1 and value for in repeat. It doesn't really matter because we're not doing anything with that yet. We'll put in 3. And if you look at the output of this mask we've created, it's set up and returns an array, and the array is 0, 3, 5, 9, 15, 18. It returns all the positions of our number in the array. So here's NP where r equals number, and then we just called it 1. If you print 1 out, you can see we just get a nice list of indexes, and this is really useful to us. Let's go back in here, and then we can very simply on the indexes do if we have our n, and we'll do less than or equal to the length of our 1. And remember, this is a tuple coming in this array. So we have the first part is the actual indexes, and the second part is our D type. So we really want to do the 1 of 0. And this is important. If you haven't worked with Numpy arrays, or even if you work with them a lot, sometimes you just do a quick printout to find out what it is you're looking at, so you can remember the format on there. And we'll do this if it's less than or equal to the length of 1 of 0, then we can simply print 1 of our 0 position, And then on here we want to do, since that's also itself is array, we want to do the n minus 1. Because remember, we start with 0. So if we wanted to find out how many is in there, or what the position it is, we're counting 1, 2, 3, but the array is 0, 1, 2. So we have to put that n minus 1 in there. And of course, if we don't find it, we'll do an else statement, and we'll print there aren't, and then we'll go ahead and put down a placeholder just so we can keep track of it. Occurrences of 1. Just keep it simple this time. And then finally, we'll go back here, and you had our original if number in the R. We, of course, have an else. Print that it's not in there. Boom. And let's go ahead and run that. And we have our list down here. Let me move this thing back up so we can see what the run looks like. We'll look for, let's look for 1, and we want it to repeat, have a 4th, and it returns it in position 9. There we go. And if we went up here and entered in, let's enter in just a random number. I don't see the number 33, so we'll put 33 in there. 33 not in the array. So it doesn't even go through because we put that initial test right at the beginning that says, hey, if it's not in here, don't even bother. And then we went through and counted them. Now, you probably found your own solution. Very central to our solution was the where statement, where it's going to map out the indexes of this occurrence where r equals number. And this is part of masking. There's all kinds of ways to mask your data. Usually you mask the whole array across something when you talk about masking. In this case, we're just returning a simple array where it lists the indexes. Let's go ahead and clean our screen here for Part 5. Generate a dictionary that contains pairs such as I, I times I, where I integer is between 1 and an entered value. Sometimes I'll break these up if I'm for readability, so we'll do that. There we go. So we're going to generate a dictionary. That's the first thing we need to do. And we need a value entered. So let's go ahead and do both of those. And there's a couple ways to generate a dictionary. Earlier we did the 2 squiggly brackets. You can also just do d equals dictionary. And if I run this, you'll see that it works and asks for a number. Let me go ahead and enter in 4. And it processes. I could have easily just have also done this with the double brackets. That's the same thing. So if you see something dictionary, you could also, these are equivalent statements. D equals brackets and D equals dictionary, or the dictionary object. And we'll do for I in range, 1 in plus 1. So there's a number we entered. And in our dictionary, we're going to do D of I. There's our key, equals, and our value, I times I. And you could have also done, since this is just squaring it, we could have also done squared. That's the same thing as I times I squared. But we'll go ahead and do I times I, and then we'll simply, because you want to see what your end is print D. And let's go ahead and run this. And we'll shift this up just a little bit. It says enter a number, we'll enter 3, and if I run that, or if I hit enter on there, I get 1, 1, so 1 squared is 1, 2 squared is 4, 3 squared is 9, and you could go on as far as you wanted on there. I could enter in a significantly larger number, but it goes up to whatever my range is on that. This is again an example of dictionary, how to build a dictionary in simple ways on there. Alright, let's go ahead and clear our screen for part 6. Write a program which takes 2 digits, x, y, as input and generates a matrix. The element value in the ith row and the jth column of the array should be I times j. There's a lot of ways to do this. We're going to do this as a list of lists. My first thought, though, would be to put this in Numpy, because Numpy can do this there's a lot of automated ways to do this in Numpy. But let's go ahead and look at the back end. How would you do this into a regular list? So before we start solving this problem, how do we get our data? We have 2 inputs. What if I wanted to have just one input, where I have you enter x, y? What would that look like? Take out the space there because that could cause an issue. Well, there's a couple ways to do this. One is if we want to generate an xy, this member is going to return a tuple for whatever I do. We could do something like this. So on here, we're entering a string with 2 integers. How do we convert those? Well, we can do integer x for x in string.split. This is a really kind of a fun shorthand for Python for iterating through our setup. So what we got here is we're going to first of all split our string. So here's our string. It comes in with 2, 3, and then we take and we split it by the comma. And for each entity in that split, we want to return the integer of that entity. In this case, we've labeled it x. And so this should go through and do x, y, and it should return an x integer and a y integer. And let's just see what that looks like. Let me just go ahead and print x, y. And let's go ahead and run that. And here our xy is. We go 3, 2, hit enter, and it enters 3, 2. Now, if you're putting out a full package, what happens if you have somebody who's overzealous and does something like this? 345, 3, enter. We're going to get it unpacked too many values. So this returned this huge list of numbers I typed in and gave me an error. So you got to remember that when you're doing these different inputs, you might sort it out and just look for the first 2 of them. There's all kinds of different ways to do this. So now we have our xy. If you went ahead and just did the enter x and enter y, that's okay. And we want to generate a list. So our list that we're going to put together is going to be, and again we're doing some nested stuff here, which is a lot of fun. We're going to create a 2 by 2 matrix, and so we're going to have for column in range y and for row in range x. So what we're doing here is this is going to put a 0 in each of these in here, and then this is simply column is our for column. Column is nothing more than a placeholder. I could have done for C in range Y. Same thing with row. That's because it has to have a value that shows up here. And we're just going to fill everything with 0. And let's go ahead and print this. Print list. We run this, and you'll see here's our enter xy. We'll do 3, 3, and we end up with 0, 0, 0, 0, 0, 0, 0, 0, 0. Here's our 2 iterations done the Pythonian way. It's going to return, you have the square brackets on the end, so it's returning an array. And for the first one, we're going to put 0 for column in range of y, and then we're going to repeat that again for row in range of x. Instead of 0, we can simply do this. I can do column times row. And if we run this, we'll see here's our xy. Let's do 3, 3 again. That way it's not too big on there. And we end up at 0, 0, 0, 0, 1, 2, 0, 2, 4. And we might get a little fancy in this and do, oh, you know what? Let's do it this way. Import numpy as np, and then maybe we'll do numpy array equals np.array of, and then we'll enter in our list that we created, and then let's print npa. Remember that when I see here matrix, I automatically go right in for the numpy array. So we'll enter our 3, 3, and you can see here that numpy is designed for doing matrices. And so we have 0 times 0, 0 times 1, 0 times 2, 1 times 0, 1 times 1, 1 times 2, and so on. So we create a nice little matrix of I to j. And then we put it into numpy just because we can. And numpy has such a nicer format on there. So let's go ahead and clear our palette. Let's move on to part 7. And in part 7, we're going to find the HCF of a 2 numbers using recursion. And HCF, if you don't know what HCF is, it's highest common factor or denominator of 2 numbers using recursion. I couldn't remember it. I had to look that up. So let's do a definition. We'll create our little function, HCF. And what comes into there is going to be x and y. And what I want to know is we want the highest one, so we'll do if, first of all, y is not equal to 0. If it's equal to 0, you don't want to divide it anything because they'll give you an error, anything divided by 0. And let's take that and we're going to just return HCF of y, comma, x, and here's a remainder of y. So HCF y of x of remainder of y. So we're looking for, this is just the remainder. So it's going to return the remainder on here on this. Else, we want to return x. And so we would need our input on this before we go any further. So let's grab a input, and we'll do the same kind of input we did before. We're entering x and y, enter 2 positive integers. And this is just from a previous example. So we'll just go ahead and grab the integer x for x. And in this case, it's not string. Keep it the string on there, st, and have our 2 integers here from before. Keep it simple. And then let's just go ahead and combine it all into one line. Pythonian way. If you can put it into one easy to read line, then you should do so. So we're going to print HCFF of placeholder D, and placeholder D is placeholder D. And this is our x, our y, and then we're going to just print out the return value of our HCF of xy. Now let's go ahead and run this. We're going to enter in 2 positive numbers. Let's go 12 and 18. And so the HCF of 12 and 18 is 6. That would be our most common denominator. Let's go ahead and clear out part 7, and then bonus. We are going to throw in a part 8, quick sort. So we have bonus round part 8, quick sort, and we're going to positive list of integers. So we're going to do a quick sort on positive list of integers on here. There's like so many different ways to do different sortings on this. One of the ways to do it is to look at our list and then partition that list. And then you go through that partition and you sort it, and then you sort a smaller list and a smaller list and so on and so on. So that's what we're going to do on this one. Before we start though, we do need to go ahead and grab our data and set that up. And so you can do it a number of different ways. We can do comma separated. We're going to switch it up a little bit on this one because it's just fun to try different things. And we're going to do enter in number of objects in the list. We're going to enter each of those values into our array. In our array, we're just going to input an integer of them, print the original list. This should be pretty familiar because we've done so many inputs in this lesson and the last lesson. All we're doing on this one is we're just appending the input here and how many inputs, and so it'll go down the list. And if we go ahead and just run this first piece of code real quick, number of objects in the input, we'll do 3. Values of the objects, we'll do 3, 2, 5. And you can see here's our original series, 3, 2, 5. Pretty basic and straightforward. And because for me space is a commodity as far as our output and the screen I have for your catching you on what you're reading there, we'll just put it on one line. We'll say original list. So the first thing we want to do is if we're going to do partitions, let's create a module for partitioning out our data. And so we'll start with a simple definition, procedure, and we'll call it partition. And we want to take our list that it's sent. We want a low value, a high value. And what we're going to do with this is we're going to create I equals low minus 1. So remember, this is an index, and we actually started with 0, so now we're actually 1 less than the index if we're initiating this with 0 on one end and the maximum on the high end. And we'll call it pivot, and the pivot is going to be a value. We'll set that list equal to our list of our high index. So remember, high and low are indexes. I is an index. Pivot is a value. That's the actual value in this position of whatever we send it. So we're going to send it 2 pointers, low and high, and we're going to send it the list. And when we initiate this, we usually will set it up as a first entity, which is index of 0 for low, and then for high we'll have the highest index on there. Then we need to go ahead and do for j in range, low, comma, high. So we're going to go through all the different values in there, and if list of j is less than or equal to pivot, then I equals I plus 1, but we like to do it the Python way, so plus equals 1. Now remember, we subtracted 1 up here, so this is 1 less than whatever index we sent it, which if we start with 0 would be minus 1. And this brings it back up to 0. So this is why we put this in here at the top part. I'm actually going to stop here just for a second, because sorting is one of the most basic things, but it's very confusing as to why the sorting is so difficult. And one of the reasons it's so difficult is because if I have the numbers 3, 2, 1, there's so many different ways to sort this. One, I could take and look at these two numbers, and if this value is higher than this one, I could swap them, which would then give me 2, 3, 1, and then I can look at these two numbers, and if this is bigger, then I can do swap them, and then I get 2, 1, 3, and then I got to start over because now the 2 and the 1 aren't in order. And so you can see with the lengthy list, whatever I do starts running into factorials, n factorial runs. And there's no real easy way around this, because if I put a reverse list 3, 2, 1, it's going to maximize how many runs it takes. And so finding different ways to sort the data depending on what you're doing can be really confusing. So understanding just what's going on with this particular sort we're doing helps to start understanding where this problem occurs, and certainly there's tools out there to sort it for you which are already maximized. Sometimes you have to sort on values that aren't, the value you're sorting on might be different. It might be, instead of sorting on j, it might be the remainder of j divided by something, or it might be the percentage of j over another column. So being able to sort these things is important, and knowing how this works, the logic behind it, is more important than the actual coding at this point. So we get in here, we go I equals I plus 1. So remember that I put, in this case, we did it somehow reverted there. I plus equals 1. And then we're going to do list of I, comma, list of j equals list of j, comma, list of I. And this is just a cool Python way of swapping values. You can see here we have ji becomes ij. So we're swapping the values up here as we go through this partition on right here. And this works on our counting because we have I, which right off the bat is set to 0. We have high, which is not the end value, but one less than the end value. So our range of j is going from 0 to not quite the last digit. And our I is going from, we've added the +1, and then it goes to the end here. So we have our list of I, our list of j, and we swap them out depending on if list of j is greater than pivot. And we can also do something like this. Here's our pivot. We'll just take our pivot out up here. So here we have our list of high is going to be our pivot number that we're switching around, and we're just iterating it through and swapping values. And then finally, we'll go ahead and run this one more time. List of I plus 1 of list of high equals list of high comma list of I plus 1. So one last swap at the end. Now, if you're looking at I equals low minus 1, let's do this. This is kind of fun to do. Clean up our code a little bit. I'm incrementing it right here. Why? I don't know. I can increment it right afterwards, and it has the same result of taking the -1 off of here and just adding it after I need it. And this then carries down to here where I have I plus 1. Well, I'm adding it at the end, so I don't need to add it again. And we simplify it down to I equals low. Following our I's through there, we have list of I, list of j, list of j, list of I swapping. Here's our increment, and then our final swap at the end. And what we want to go ahead and do is we just want to return I plus 1. And so if we're going to have our partition set up this way, where we're returning the I plus 1, or in this case just I, we want to return I. Carried it down, forgot to carry it down there. We've taken our list, we've swapped it around because we're passing the list. We're passing the actual list, not just a pointer to it. And then we're going to return the I so we know what we did. And so if you remember down there when I did that example, the first time through we swap it around, and then it comes up and says, oh, okay, we've already swapped the high value all the way up to the right-hand side. Then we have to start over. So we'll go ahead and call this quicksort. And the quicksort is going to take the list, a low, and a high, just like we did for our partition. And what we want to do that is if low is less than high, then we want to go ahead and partition the index. Let me fix my tabs. There we go. So PT is the value from the partition that's coming back. That's what this I returned. And so we would go ahead and partition our list, and we have our low and high value going in there. If we're going to partition our list, once we get the PT back, we can go ahead and do a quick sort on the same list, low comma PT minus 1. So it goes through the list, it moves the highest value to the end, and then we want to take that PT it returns and we want to subtract 1 because we know where the high point is. So now we have a shorter list to go through. And we sort it from the other end too. We'll do a quick sort and we'll do our list comma PT plus 1 comma high. So we're coming out from the other end. So we're basically sorting the list going both directions on here. So this is our sort on this one. We've now sorted our list, so we need to go ahead and call that. And we can simply call that, let's see. Oh, we can print out the list. Let's do this. Let's go print. There's our original list, a sorted list, and we'll put our little placeholder. Or you know what, we won't put a placeholder there. We'll just put a comma in. And of course, it probably helps to actually return the list. So we'll go up here and do return list that we've nicely sorted on here. And we'll come down here to this part and do quick sort. And we have our list that we put in. We're going to start with 0 for initiating it. And then we have our high value, which is simply the length of the list. Because that points to, it's actually length of the list minus 1. That's going to point to the last index. And then real quick before I run this, let's do some quick cleanup here. The original list, and then we want to create a second list which equals the original, and then we're going to print our sorted list and we're going to send it this information for our quick sort. So let's go ahead and see what that looks like. Let's go ahead and run this, and we're going to enter our number of values. We'll just do 3, and we're going to enter in 3, 2, 1. Let's open this up so we can see what's going on down here. So here's our original list, 3, 2, 1, and you can see it's nicely sorted, 1, 2, 3. And if I was testing this out, I would enter in 1, 2, 3 to see what happened. I would enter in 2, 3, 1. Just some quick changes to make sure it's sorting correctly. In fact, let's go ahead and do that real quick. Let's go ahead and enter another list. We'll do it 4, and I'll do 1, 2, 3, 4. 1, 2, 3, 4 sorts out as 1, 2, 3, 4. And I actually know from doing these so many times that that's more than enough on these. But just in case, let's go 2, 1, 3, 4. And 1, 2, 3, 4. There we go. Quick sort for our list. Certainly the questions we're going to ask in here are very general with a few specifics towards data science, since that's the main direction that Python's going in. And you'd want to expand your questions for your interview depending on the domain that you're using the Python in specifically. Let's dive in and get started with some Python interview questions. Number 1, what is the difference between shallow copy and deep copy? And you can see with shallow copy we have object 1, which has child 1, child 2, child 3, and so on, and object 2, which has child 1, child 2, child 3. A deep copy creates a different object and populates it with the child objects of the original object. Therefore, changes in the original object is not reflected in the copy. Copy.deepCopy creates a deep copy. Shallow copy creates a different object and populates it with the references of the child objects within the original object. Therefore, changes in the original object is reflected in the copy. Copy.copy creates a shallow copy. And you can look at this. If we make a change to child 1, it's only a pointer. So if you make it in object 1 and a change to child 1 in object 1, it will also make that change in object 2. Number 2, how is multi-threading achieved in Python? Oh, this is a good one. With multiprocessing and multi-threading, this question is actually asking you, do you know the difference between multiprocessing and multi-threading and how multi-threading works? Multi-threading usually implies that multiple threads are executed concurrently. The Python global interpreter lock doesn't allow more than one thread to hold the Python interpreter at that particular point of time. So, multi-threading in Python is achieved through context switching. It's very different than multiprocessing, which actually opens up multiple processes across multiple threads. So, multi-threading. Discuss the Django architecture. So the Django architecture, and the first thing to know is that the Django is a web service, way to build your web pages basically. And so when you look at the architecture, you can see here we have a nice model drawn out where the user initiates the Django, which initiates the URL, which initiates the view, what they're going to view, and you have your model and your template. So the model of data, whatever data model you're pulling, goes into the template and then goes back up the pipeline to the user. And the important thing to note is there's a template, the front end of the web page. This is what they're going to see. There's a model, the back end where the data is stored. So you can keep the template and the looks and everything looks the same, but you can swap out the underlying information that goes into that template. Then you have your view, which interacts with the model and template and maps it to the URL, and then the Django serves the page to the user. So your Django grabs it and says, okay, thank you for the URL, and here you go, user. What advantage does Numpy array have over nested list? So Numpy is a module you import. Almost always see Numpy, import Numpy as NP. Numpy is written in C, such that all its complexities are backed into a simple to use module. Lists, on the other hand, are dynamically typed. Therefore, Python must check the data type of each element every time it uses it. This makes Numpy arrays much faster than lists. I would also add in that Numpy has a lot of additional functionality that you don't have in lists. So there's a lot of things you can automate in the Numpy. Quick flip over to our Jupyter notebook. Any IDE will work. If you're going to do a set of interview questions, taking a quick look at code is always important. We have our import Numpy as NP. We'll go ahead and import time. Here's our list sub for I in range of 100. And all we're doing is we're going to time it. So we're going to create a list. Then we're going to create a Numpy zeros array. And you can see here, look how quick you can create this Numpy zeros array. Here we are appending 1 0 at a time for a regular Python list, and here we are with Numpy. They're all zeros, and they're all of type integer. I believe it's either float or integer on this. I'd have to actually do a type on it. And then, so if we take in and we create a TL1 time equals time, and then we do for I in range of 100, for j in range of 100, L of I, j equals L of ij plus 5. So we're just doing a simple calculation on our array and subarrays. This is an array of arrays. And we'll do the same thing with TL2. TL2 time.time, TL1 equals, so here we have our final time on that. And then we'll do this with an array op, and this is what I really love, a equals a plus 10, and then you can just print it right out. So you can see right here with the Numpy array, we're doing the same thing. If I run this, our time is significantly different. Here we have 0.09 and 0.003. So you can see that the time drops significantly when you're running this on a Numpy array versus a list array. Also important to note, these times aren't going to be, they'll change each time I run it depending on what I have running in the background. So there we go. Number 5, what is pickling and unpickling. Amazes me how many times I pickle and unpickle something. Converting a Python object hierarchy to a byte stream is called pickling. Pickling is also referred to as serialization. Unpickling, converting a byte stream to a Python object hierarchy, is also called unpickling. Unpickling is also referred to as deserialization. So if you just created a neural network model, you can now save that model to your hard drive, pickle it, and then you can unpickle it to bring it back into another software program or to use at a later time. How is memory managed in Python? Number 6. Python has a private heap space where it stores all the objects. The Python memory manager manages various aspects of this heap like sharing, caching, segmentation, and allocation. The user has no control over the heap. Only the Python interpreter has the access. You have a nice little diagram here. Here's your program. There's your interpreter. We have our heap, memory management on the garbage collector going off of there. Number 7. Are arguments in Python passed by value or by reference? Arguments are passed in Python by reference. This means that any change made within a function is reflected on the original object. So you can see here def function of L of 0 equals 3, L equals 1, 2, 3, 4, function L, print L, and you're going to get 3, 2, 3, 4 because we passed L in there, so it's a pointer. Here we have def function L equals 3, 2, 3, 4, L equals 1, 2, 3, 4, function of L, print L. Because in this function I have assigned, instead of operating on a piece of L, the list, I've assigned a whole new value to that list, or L. It then at that point will create a new object. So if I make changes to the object, it's going to change it in the outside the definition. If I use a variable and I assign it a completely new value, like L equals 3, 2, 3, 4, that will not show up when you're outside the function. Number 8. How would you generate random numbers in Python? To generate random numbers in Python, you must first import the random module. The random function generates a random float value between 0 and 1. The random range function generates a random number within a given range. And you can see here 1 is the lower end, 10 is the upper end, and step 2. So it would be 1, 3, 5, and so on as far as the options in the random generation. Number 9. What does the double forward slash operator do? In Python, the forward slash operator performs division and returns the quotient in float. For example, 5 over 2 returns 2.5. To do a double forward slash operator, on the other hand, returns the quotient in integer. For example, 5 double slash returns 2. 5 divided by 2 and you drop the 0.5. Number 10. What does the is operator do? The is operator compares the ID of the two objects. And you can see in here where list1 equals brackets around 1, 2, 3, list1 equals list2 equals true. And you have the double equals in Python, of course. And you can do list1 is list2, where list2 equals 1, 2, 3 is false. List2 is not the brackets 1, 2, 3. It equals it, but it's not the brackets. And if we do list3 equals list1, then list1 is list3 equals true. Number 11. What is the purpose of pass statement? The pass statement is used when there's a syntactic but not an operational requirement. For example, the program below prints a string ignoring the spaces. And so here we have variable equals Simplilearn. We've added 2 spaces in it. For I in variable, so it goes through each I. If I equals space, do nothing. Else, print I, and then we'll have the end equals bracket bracket, and they'll print out Simplilearn. Now, of course, you would probably write this if I does not equal blank space, print. But this would be another way you could do that if you need a placeholder for that first logical set or that first area. And you can also do a function like this. You could do function, whatever your def function name, brackets, colon, pass. So it goes into the function and does nothing, but it's a placeholder. Number 12. How will you check all the characters in a string are alphanumeric? Python has an inbuilt method, isAllNumber, which returns true if all characters in the string are alphanumeric. And so you can see here, ABCD, 1, 2, 3, isAllNumber, output equals true. And the second line, ABCD, the @ symbol, 1, 2, 3, the pound symbol, isAllNum, output equals false. So really you just want to know about is all numerical, alphanumerical. Number 12. How will you check if all characters in a string are alphanumeric? So here we go. If you know is all number, which returns that the characters in the string are alphanumeric, one can also use regex instead. And so we have Boolean RE match. What's important about this is to note your capital A dash to capital Z, A lowercase to dash to Z, 0 to 9 means that that array includes all of those, the way they have it written out, plus a $sign, and then we have what we're comparing it to, the string we're comparing to, the ABCD 1, 2, 3. And so we can do an RE.match, and if it matches, if all these things, if all the different entities in that array matches the first one, we get an output true, and if not, an output false. Number 13, how will you merge elements in a sequence? Sequence. There are three types of sequences in Python. There's lists, tuples, and strings. Python, of course, makes this easy. If we have a list 1 and list 2, and list 1 is square brackets 1, 2, 3, list 2 is 4, 5, and 6, we can simply do list 1 plus list 2. And our output is 1, 2, 3, 4, 5, 6. If we have tuples, your tuple is the curved brackets designates it, and again, just add them together. Same thing with strings. We have Simplilearn, S1 plus S2 equals Simplilearn. Number 14, how will you remove all leading white space in a string? Python provides the inbuilt function lstrip to remove all leading access from a string. And you can see here, space python dot lstrip, leading strip, Python. And you can also do strip, which relieves leading and ending. And of course, there's also the ending set. Number 15, how will you replace all occurrences of a substring with a new string? The replace function can be used with strings for replacing a substring with a given string. Syntax: string.replace old, new, count. Replace returns a new string without modifying the original string. Hey John, how are you, John? Question mark. Replace John with capital JOHN 1. And then you can see right here, hey John, how are you? And since we designated with the 1, just says we're only going to replace one of these. 16. What is the difference between del and remove brackets on lists? Del for delete. Del removes all elements of a list within a given range. Syntax: del list start to end. Remove. Remove brackets removes the first occurrence of a particular character. Syntax: list remove element. And we see a nice example over here. If we delete the list 1 to 3, it will delete the first, in this case B 1, 2. It doesn't do 3, remember that. 1, 2, so it will delete B and C and you end up with a D. Where if we do remove B from the list and we have an A, B, B, D, it's only going to remove the first B. Number 17, how to display the contents of text file in reverse order. Open the file using the open function. Store the contents of the file into a list. Reverse the contents of the list. Run a for loop to iterate through the list. Number 18. Differential between append and extend. Append adds an element to the end of the list. You can see right here we have a list 1, 2, 3, 4, and we append 4, and we end up with an output 1, 2, 3, 4. And extend adds an element from an iterable to the end of the list. And we have here list equals 1, 2, 3, list.extend 4, 5, 6. Output is 1, 2, 3, 4, 5, 6. So if you want to append an array to the end of another array, you want to use the extend. Number 19, what's the output of the below code? Justify your answer. This is a great interview question because these are the kind of things that come up when you're proofing code. Def add to list, value, and list. So we have value in and a list in, or list equals an empty, in this case an empty list. List.append value, return list. List 1 equals add to list 1. List 2 equals add to list 1, 2, 3, empty bracket. List 3 equals add to list A. And then we want to print them. List 1 equals, and you can see the formatting. We have our placeholder, list 1, list 2, and list 3. So when it prints list 1, we get 1, comma A. And what you want to notice here is that list 1 and list 3 are equal. Why are they equal? Well, when we passed the information to the add to list, we passed value without passing the list equals brackets, without passing a second value. What this means is that list, as we have it, if you don't have a list, it'll start off with empty list, which we append the 1 to. The second one, list 2, we appended a value to an empty list. So it's only going to be 1, 2, 3. It doesn't matter what the list was before, we've already assigned an empty list. And then list 3, here's the tricky one. We're adding A to the list, but because we didn't designate the list, list is a shared value. In other words, it doesn't reset it. And we end up with list1 equals list3, 1, a. Default list is created only once during the function and not during its call. Number 20. What is the difference between a list and a tuple? Lists are mutable while tuples are immutable. And you can see an example down here where I have list equals 1, 2, 3. Square brackets denote it's a list. List of 2 equals 4, and I print it out and I now have 1, 2, 4. If I do the same thing with the tuple, I get an error, because you can't change the tuple 1, 2, 3 into 1, 2, 4. You have to completely reassign tuple to a new value. What is docstring in Python? Docstrings are used in providing documentation to various Python modules, classes, functions, and methods. And so you can see here we have def for our function add AB, and this is a docstring. We have the triple brackets on there. You can add carriage return in that so that you can go multiple lines. And it says this function adds 2 numbers. And then sum AB returns sum. And so we have down here 2 different ways of accessing this function. Output, accessing docstring method 1, this function adds 2 numbers. Accessing docstring method 2, help on function add in model main. This function adds 2 numbers. And so you can see the code down here has 2 very different end values. The second one is basically a help menu. There's our help menu. Number 22, how do you use print without the new line? The solution to this depends on the Python version you are using. In Python version 2, you can do print hi and then you add a comma afterwards. Print how are you? And you have hi, how are you? In version 3, print hi, comma, end equals, and it'll add a space on the end there. You can put different characters in there, but generally you just want to put a space on the end. Print how are you, and now we get hi, how are you? Number 23, how do you use the split function in Python? The split function splits a string into a number of strings based on a specific delimiter. So we have string, split, delimiter, comma, max, the maximum number of splits. The character based on which the string is to split by default is space. So here we have an example. We have a variable red, blue, green, orange, and we want to split it by commas, and we only want to do the first 2. So if we print the list now, you'll find it has red, blue. It only split it the first 2 times, and then it gets to the third one and just groups them all together, green and orange. If you leave the 2 off, it'll split the whole thing. Number 24, is Python object-oriented or functional programming? Python follows object-oriented paradigm, and you should really know in depth what they mean by object-oriented paradigm if you're doing any interview for scripting languages. Python allows the creation of objects and its manipulation through specific methods. It supports most of the features of OOPS, which has inheritance on a polymorphism. So you have an object and you can inherit all the traits of that object and then add new traits in or alter some of those traits. That's what object-oriented means. Python follows functional programming paradigm. Functions may be used as first class object. Python supports Lambda functions, which are characteristic of functional paradigm. So you can set a variable to a function as opposed to setting it to an object. Number 25. Write a function prototype that takes variable number of arguments. Here we have def function name list. So we could have, in this case, whatever the list is, def function. The asterisk denotes that we're going to take multiple arguments of a variable, and then we can do for I in var, print I. So if you send function of 1, you'll end up with a function 1, 2, 5, 6. It'll actually print those out one at a time. The first one just prints out a 1 because it only sent 1 variable. The second one will print 1, another line 25, another line 6. Number 26. What is asterisk args and asterisk quargs? Args used in function prototype to accept varying number of arguments. It's an iterable object, def function args. And you can imagine it's just a basic list. So if I add the numbers a comma b or a comma b comma c, it doesn't really matter. It will have that number of objects in it, whatever I send to it. And there's other uses for it, but that's very basic. Quargs, I can actually tell it what I want to send. So used in a function prototype and to accept varying number of keyworded arguments. Both are iterable objects, so you can go through them one at a time. And the def function quards, you can now set like color equals red, units equal 2. So you'll see that, especially in machine learning, there's a lot of they'll have inline equals true, that kind of thing. Number 27. In Python, functions are first class objects. What do you understand from this? This means I could return a function, be one from another function. I could create a function and treat it just like an object. I can assign it to a variable. I can pass them as arguments to other functions. Number 28. What is the output of print name __ name? Justify your answer. The double underscore name double underscore is a special variable that holds the name of the current module. Program execution starts from main or a code with 0 indentation. Thus, double underscore name double underscore name has a value double underscore main double underscore in the above case. If the file is imported from another module, then double underscore name underscore double underscore holds the name of this module. Number 29. What is a Numpy array? And we briefly touched Numpy array compared to a list early in processing speed. Now let's go ahead and look at some of the more specifics. A Numpy array is a grid of values, all of the same type. So if they're either all float, all integer, all string, and is indexed by a tuple of non-negative integers. The number of dimensions is the rank of the array. And the shape of an array is a tuple of integers giving the size of the array along each dimension. Number 30. What is the difference between matrices and arrays? A matrix comes from linear algebra and is a two-dimensional representation of data. It comes with a powerful set of mathematical operations that allow you to manipulate the data in interesting ways. Now, an array is a sequence of objects of similar data type. An array within another array forms a matrix. Like we said here, two-dimensional, so if you have an array of 3 by 4, that would be a matrix. Number 31. How to get indexes of n maximum values in a Numpy array. Of course, the first thing to do is to import your Numpy as NP. You don't necessarily have to use NP, but that is the most standard use of Numpy. We create our array equals an np.array of 1, 2, 3, 4, 5. And then if we want to get our indexes of n maximum values in a Numpy array, we can do, one way to do it is to take our array, sort it, then do -n colon. That means we're going to do, once you've sorted it, you can do -n. N would equal then the number of indices, so it's not the actual letter n, colon. And really this is about understanding this notation, that we can sort it, so it goes from lowest to biggest, and then we can get the top values for n indexes. And then we have our final set of brackets with the -1 on there. Number 32. How would you obtain the resulting set from the train set and the test set from below? And let's go ahead and look at the two different variables. We have train set equals an array of 1, 2, 3. Test set equals a Numpy array of arrays. We have 0, 1, 2, 1, 2, 3. What's important here is that, one, it's a Numpy, so that leaves A out, and then we're stuck with 3 other options, and I'm going to say that D is out, none of these. And let's look at np.concatenate versus np.vstack. Concatenate would put one set after the other, so you would end up with, probably give you an error, because one set is 1, 2, 3, and then we're going to concatenate array 0, 1, 2 and array 1, 2, 3, the array of arrays, onto the end of that. What we really want to do is stack, and by the way, you can actually switch, there's variables you can put into concatenate obviously that can change this, so you could use the concatenate with a lot of fudging around. But really what we're looking for is VStack. V stands for vertical versus the HStack, which is horizontal, and if we do a VStack we can simply do train set comma test set and stack them together. And so we have C, resulting set equals np.vstack train stack test set. Both option A and B would do horizontal stacking, but we would like to have the vertical stacking. Option C does this. Again, you could add the axes in and use the concatenate to stack it the correct way. Number 33. How would you import a decision tree classifier in sklearn? We have sklearn.decisiontree import decision tree classifier. From sklearn ensemble import decision tree classifier. And we look at these and they're all import decision tree classifier. That actually last part happens to be correct, and it's really just a vocabulary knowing where is the decision tree classifier stored, what module is that a part of, and it is of course part of the sklearn.tree. Number C. Number 34. You have uploaded the data set in CSV format on Google Spreadsheet and shared it publicly. How can you access this in Python? What's important here is to know that we can read stuff with pandas. So we don't show it here, but you can, there's actually a number of ways to do this. What's important here is to know a couple things. One, we have our link generated from the Google Docs and spreadsheets, and then we can do a stringio request get link.content. So there's our source. And then finally, we know that pandas can read a CSV. There's obviously many ways to read a CSV, but data equals pd.read_CSV source. Number 35. What is the difference between the two data series given below? Below we have df name and df location, colon, comma, brackets around, asterisks around name, comma, where. And then we have df equals pd data frame, AABBXXUU, comma, 21, 16, 50, 33. Columns equal name and age. So let's take a look and see what they're looking at. We have, just glancing at the questions, they want to know, is it the original data frame or is it the copy of the data frame? And you can see here that 1 is view of the original data frame and 2 is a copy of the original data frame. 2 is a view of the original data frame and 1 is a copy of the original data frame. Both are copies, both are views. And if you're working with pandas, you know that unless you specifically in certain things tell it to do it inline, and a lot of functions don't allow you, that you're always taking a slice and it is always a copy. So C, both are copies of the original data frame. Number 36, you get the following error while trying to read a file, temp.csv using pandas. Which of the following could correct it? So here's our error. Trace back most recent call last, file input, line 1 in module, Unicode encode error. ASCII codecs can't encode character. Ooh, I hate it when that one comes up. And we have 4 different entries. We'll go ahead and just pretend that D doesn't exist unless we really can't fit it into one of the other answers. And the first one is PD read CSV has our file compression equals gzip. Well, gzip is just an unzipping and you actually get a zip error on there. The second one is dialect equals string. Again, not an encoding or coding setup. And then we have encoding equals UTF-8. Well, that would be the encoding error, switching it from the character code. There's UTF-8, there is Unicode. That's the most common two that it goes between. So really this is about understanding the difference between a UTF-8 coding and a Unicode and the error that comes up quite regularly with that. Number C, encoding should be UTF-8. Number 37. How to set a line width in a plot given below. So looking at this, we have import matplotlib, pyplot as PLT, and you should know your way around this, how to do a plot in there. PLT.plot 1, 2, 3, 4, plot equals show. And so this is a little bit of a vocabulary test. The vocabulary is at width equals 3, line width equals 3, LW equals 3, or something else. And the vocabulary word that we're looking for is LW equals 3, which stands for line width in pyplot library, pyplot. Number 38. How would you reset the index of a data frame to a given list? So this is a vocabulary challenge in understanding what reindexing is. Reindexing, as we have the different values here, we have the first one, which is reset the index. Well, we're not really resetting the index. Reindex number B means we are double checking our indexes to the column and to the main index, and so the values match correctly. Where reindex like now brings in a new index outside of our data frame to a given list. So this is coming from external, and thus the vocabulary word like is our key word, that it's external, and we have a data frame to a given list. Number 39. How can you copy objects in Python? The functions used to copy objects in Python, we have copy for shallow copying and copy deep copying for deep copy. Number 40. What is the difference between range and xrange functions in Python? Well, this is a good one. We have matrices and arrays. With a matrix, the range returns a Python list object. Xrange returns an xrange object. And with arrays, an xrange returns an xrange object. Xrange creates values as you need them through yielding. The key here is that xrange returns the values as you need them. So it actually processes it post, like if you have for x or for a variable in xrange, it is processing them as you need them, 0 to 9. It doesn't create an array 0 to 9, it just hands you 0, then 1, 2, 3, 4, 1 at a time. Number 41. How can you check whether a pandas data frame is empty or not? The tribute df.empty is used to check whether a pandas data frame is empty or not. And so you can simply create we have down here import our pandas as PD. We create our pandas data frame equal to an empty array, and is df.empty comes out as true. One of the catches you got to remember with these vocabularies is with empty along with some other pandas setup, whether you need the brackets or not at the end. Number 42. write the code to sort an array in Numpy by the n-1th column. This can be achieved using argsort function. Let us take an array x, then to sort the n-1th column, the code will be x to colon n-2.args_sort. So let's see what that code looks like. We import Numpy as np. We'll create our array, our Numpy array, which is 1, 2, 3, 0, 5, 2, 2, 3, 4. So we have 3 different entities with 3 different columns in there. And we go x of x, and so we take x of all the rows, first entity, or in this case it's actually the second one because it's 0, 1, 2, dot argsort. So that would be the second entity, or -2 would also be the same. You could also do, instead of 1, you could also do -2 there instead of the 1. Argsort, and then we get an output of the array 1, 2, 3, 0, 5, 2, 2, 3, 4. Number 43, how to create a series from a list, Numpy array, and dictionary. So we'll go ahead and import our Numpy, our pandas, and have my list. And you can see here we have my list equals list of A, B, C, D, E, F, G all the way through. So my list now makes a list of that. For array, we have np.arange to 26. My dictionary will create a dictionary with zip my list, my arguments. So I'll just use the Numpy array we just created with my array to go into the dictionary. And the solution is simple with the pd.series my list, pd.series my array, pd.series my dictionary. So it's all about knowing the dot, capital S-E-R-I-E-S. Don't forget that capitalization. Number 44. How to get the items not common to both Series A and Series B. And you can see here we have, instead of Series A and B, we have Series 1 and 2, and we have 1, 2, 3, 4, 5, 4, 5, 6, 7, 8. The solution is we take a panda series, we have a series U equals a panda series, NP union 1 dimension, Series 1, Series 2. So we can now make a union of them. We now have Series 1 panda series with an intersection, and then we can remove one from the other. Series U is Series U dot is in Series 1. So if the union is not in the intersection, then you know it's a unique value. A little bit of logic going on there and playing with 3 different terms to get the answer we want. 45. How to keep only the top 2 most frequent values as it is and replace everything else as other in a series. So again, we're working with pandas, because if you're talking series and data frames, that means we're working with pandas. So we're going to import pandas as PD. We'll go ahead and create our panda series. We're going to do that by creating a Numpy random state 100, so 100 in the Numpy one. And then we have our panda series. You can see here we're random integer, Numpy random.random integer of 1, 5 by 12. And so the solution for this is we go ahead and we've created a PD dot, remember the capital S series solution. We're going to print the top 2 frequencies, and that is our series dot value counts. And then we take series values count dot index of up to 2. So we're going to take everything up to 2. And then we'll do the series is in. So if it's not in the first 2, then it's going to equal other. And this would be something you'd want to write down on paper. If it looks confusing, take a moment, pause the video, write this down, and see if you can figure out how the logic came together and try to throw yourself a couple other little logic puzzles like this. Number 46. How to find the positions of numbers that are multiples of 3 from a series. And in here we're actually going to use a Numpy to solve it. The first part, series, lets you know it's going to be a panda series. And if we come down here, we have np.argwhere, so this is a vocabulary question, series with, remember the percentile 3 is a remainder, so if the remainder equals 0, then we're going to generate that string where the object divided by 3 equals 0 has no remainder, so then we know it's a multiple of 3. Number 47, how to compute the Euclidean distance between 2 series. And this one's really cool because we have our panda series, P and Q. And what I like about this one is they give us 2 solutions you can go with. And really you should kind of know both. The first one would be, yes, you know what the Euclidean distance is. And that is we can take the first series minus the second series squared. And then sum them up, and then we do the square root, which is the same as taking the power to 0.5. Doing the power to 0.5 is easier than doing the square root. So a lot of times you'll see that as a switch, but you could have also done the square root and used the math in there. So there's solution 1, you should know your Euclidean distance. And then solution 2 is the Numpy solution. So we have np.list linalg.norm. That's how we're going to compute our Euclidean distance, p minus q. Very elegant and very straightforward and easy to compute. Number 48, how to reverse the rows of data frame. So here we have our data frame. We're going to create a Numpy array by 25, reshape it 5 minus 1. And this creates a 25 by 25 data frame. And so our solution is to do the df location. And this is just understanding how steps work. The steps, you have your colon, colon, minus 1. So we're taking all the rows, all the columns, minus 1. So we're stepping minus 1 going the reverse direction. And then we're just going to use across all the different columns on there. Let me say that again. The first colon is going to be your rows. Starting row, stopping row, step minus 1. That's all this is about, is that step minus 1, comma, and then all the columns. 49. If you split your data into train test splits, is it possible to overfit your model? And the answer is yes, is definitely possible. One common beginner mistake is retuning a model or training new models with different parameters after seeing its performance on the test set. My favorite example of this is you have your script put together and you keep hitting the rerun button until you get the answer you want, not taking the answer it first gave you, or running it over an array and recording all the answers to see how they vary. Number 50, which Python library is built on top of Matplot library and pandas to ease data plotting? The answer to this is Seaborn. Seaborn is a data visualization library in Python that provides a high-level interface for drawing statistical information informative graphs. We've covered 50 different questions that might come up on an interview. Hopefully you've taken the time to note the vocabulary where you're sticking and not having problems. You might have to go back and relook up VStack versus HStack versus concatenate, and also review the axes on those. Little things like that. Also, we address some logics. How do you formulate those different polls from a pandas data frame so that you're looking at the right data with the -1 step, or in the NP array, how we did brackets and really fiddled with it. I want to thank you for visiting us today and joining us for today's Python questions for interviews. Again, my name is Richard Kirshner with the Simplilearn team. For more information, visit www.simplilearn.com, or feel free to leave a comment down below and we will be monitoring that. Again, thank you for visiting and happy learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.